Hey guys, it's Dave from Haltech. Due to the current circumstances that we're all facing globally, I have had to self-isolate myself away from everyone else. I'm not that disappointed. I get my own little space. So I was actually going to wire this car up for a friend of mine, but we've actually pushed this forward because the marketing guys said, hey, why don't we take this great opportunity to make you do a video in front of everyone while you wire this car. So thanks, marketing guys, I really appreciate that. But we're gonna go through and do a quick step-by-step, wire-by-wire type guide so that you guys don't feel too threatened to take something like a wiring harness that looks like this, which can be very daunting to a lot of people. It's one of the funniest comments I often get when I've got a harness like this in front of me and people just go, are you serious? So we're going to go through this and break this down bit by bit to show that it's not that daunting to go through and tackle your project yourself. So this is a really quick snippet of some of the tools that help me get the job done when we're trying to wire up a car. We can just go through them really quickly. Wire strippers, really important. Really important to get a really nice pair of wire strippers. These are from J-Car, just an electronics store here in Australia. There'll be very similar stores wherever you are in the world. Every country has them, I'm almost positive. Otherwise, ordering online just to get a good pair of wire strippers is essential to get the job done really well. Crimpers, these are actually Haltech's crimpers. We sell these in sets on our web store. The link will be up in either this video or one of the next videos. Essential to get the job done. If you don't have a good set of crimpers, don't even start. It's not going to be worth your time. You're not going to have a fun time. These will help do all the sensor pins or the ECU pins that you need to do. Any relay stuff, these will come in more handy than you can ever imagine. They are very important. A good set of cutters or side cutters or angled cutters, very important too. I often have more than one around me, as you will see here in this video, because I will lose all four of these in this job, well and truly. So it's always good to have at least one good pair of side cutters, and somebody else will come and get them while I'm asleep. Somebody else will take them off to cut some metal somewhere off in the car park. So always good to have a good set nearby. These are Deutsch crimpers. These are really handy for all the Deutsch pins that come with a lot of our kits. For all the solid round pins that we supply, that's what these are going to be for. Very popular in aftermarket wire ups. These normally come from EFI Hardware, which is another Australian-based company. Very popular, so you'll be able to find these online everywhere as well. I've got my hole saw here. My hole saw is going to help put a hole where I need to run the harness through in this vehicle. Again, hardware store, very easy. A sharp Stanley knife for cutting back heat shrink or fixing a mistake that we make, because we're all human. We are going to make mistakes, so this will help get the job done. These are pin removal tools. Again, if we need to make any edits or revisions in the harness that we've made a mistake, these are very handy for this as well. So if we've got a bad connector that we need to replace, or we just happen to put the pin in the wrong hole because it's late or it's dark and you just happen to mess it up, these will be really handy. Again, EFI Hardware or many other electrical stores. Allen keys, self-explanatory. Drill bits, again, self-explanatory. Cable ties, we will go through probably a lot of these actually. Will make the cable tie man very rich, but these help neaten up the loom and make it look pretty professional. Having a good quality set of tapes is very important as well. Cheap electrical tape is good for doing handyman things. When we're doing electrical work, it is very, very important to use a good quality electrical tape. There's nothing worse than getting into a loom and seeing just goo from a bad quality tape just everywhere because it doesn't stand up to heat very well. So make sure you get a very, very good quality tape. We've got a labeler to help label some things on the loom if we need to. Some people love the look of a labeled loom. Some people don't. They like a nice, neat, clean engine bay without many labels. So we will talk to the owner and see if he wants any labels. A multimeter is also a really good tool to find out what end of this wire where it is over there. So it's always a really, really good tool to help find continuity between different wires, because we've all seen that job or that mate who said, I'll give your wiring job a go, and it's changed colours 16 times down the loom and nobody actually knows where this wire actually goes in the car. So this is quite helpful. A really good quality light is also going to be really essential for the job. Getting under dashes, under cars, in really tight nooks and crannies to try and find what you're looking at. Don't wing it. Absolutely use a light and do the job right the first time. Good quality heat shrink, a dual wall heat shrink is often very, very good, or a glue lined heat shrink is really, really helpful for really nice, tight heat shrunk looms. Using normal heat shrink inside the loom is really, really great because it's very compact, but making sure the job is secure and that the your coverings are all secure to protect your engine loom is very, very important. To shrink our heat shrink, having a little burner is very, very helpful to get that heat shrink shrunk nicely, neatly, without burning the surrounding components of that loom. A heat gun is also essential for that sort of stuff too. So depending on where you're actually doing the job, sometimes a heat gun is not handy, sometimes a little gun is very handy. It's just about learning how to use it properly to get the best result in your environment. They're probably the main tools that I use. There is a lot of other wiring things around. We'll go through those in the next couple of days. This is going to be a enthusiast level wire install. For all things very, very serious in motorsport, this is probably not going to be the right material for what you're going to use, the right sort of tools that you're going to use. You're actually going to use a much more professional level spec tool set and wire choice or wire material. For that level of motorsport wiring and how to, definitely recommend the High Performance Academy modules for wiring. They have a great set of tuning courses, and recently I've watched a lot of the wiring videos. They're incredible. So Zach does an amazing job. Definitely head across to their website. They've got some courses which are very, very affordable, and they just go through every single part of the wiring and what you would need to make a beautiful, professional looking wiring harness. This is the car. This is a 1979 to 82, somewhere in there, XD Ford Falcon. As you can see, there are a few essential components of this car that are missing. Like I said before, we brought this wiring forward simply because I had the opportunity to do it earlier than I thought. So therefore the owner hasn't actually finished a lot of this engine, but it does actually give us a lot more accessibility to everything in and around the engine, which is going to be really, really helpful. Running wires where there's not a complete car is also very, very helpful. Sometimes yes, sometimes no. Sometimes I happen to run wires where there is a very essential component of the car, so it's always a really good decision to try and get as much information about where things are actually going to go in the car as early as possible. But we're going to give it a go just in its current form. All right, let's talk about the engine that's in this car. Maybe a little bit controversial. Maybe some people don't believe that an LS belongs in a car like this. You can see why the LS is such a popular engine in most transplants these days. very small, very narrow. I've never seen this much room behind an LS engine ever in my life in any transplant I've ever seen. So much room for activities, as they say. Recently we had another workshop owner come by, and he said he actually fitted one of the forward engines, like a Boss engine, which is a dual overhead cam or a single overhead cam. I'm not sure which engine it was, but he said it essentially came out to about here. So they actually had to modify all of these strut towers and do a lot of fabrication, which does add up really, really quickly, just to make that engine fit in this engine bay. So the owner picked a nice, compact, small engine. Let me know what your comments are as to whether this engine belongs in this car or doesn't belong in this car. We'll go through it and we'll find it interesting together. So start the debate. Normally we have to think about wiring the tacho to keep the tacho working. In this original car, we used to have the tacho run off the coil negative of the ignition system. We don't have to worry about that this time, simply because the owner has decided to completely ditch the tacho altogether. The coolant gauge, the vehicle speed, everything is missing because we're going to run the IC7 display dash instead. As a wiring guy, that makes our job so much more easy, because all we're going to do is plug in the CAN communications between this and the ECU, and they'll basically talk together, and then we will have all of that display information on the IC7. As far as this void, which is missing, the cluster is currently at 3D Racing Solutions. Sam has graciously volunteered his time to actually design a new cluster for the XD-XE Falcon models, I guess. So when he's done measuring up that, he's going to draw it into his CAD system, and then he's going to bring over the first prototype hopefully in the next few days, so that we can test fit it and see how the IC7 fits nicely into this cluster, so that we can use it for a full functional display. Let's get into the harness and we'll break it down section by section, I guess, not wire by wire. That'll get a little bit tedious. It is often a really good idea to have a big working space. If you can have a bench, which is a good depth and a good length, planning is key when it comes to having a neat wiring loom. If you just run this in the car and then make it up as you go, don't get me wrong, it will work. It just won't be as neat as you might like it to be. If you can plan as much inputs and outputs, and you can have everything designed in such a way that it actually looks really neat, you end up with a nice professional looking wiring harness, which is really what everyone wants. So what we're going to do, we're going to go through and just make sure that we've got a map set up in our ECU before we even put this loom into the car. We're going to set it all up on the laptop and have a pre-made wiring, I guess you would call it an input-output schematic, that is all done in the software for the Elite ECU. We do this ahead of time and then wire from what we plan inside the map. We've got a whole bunch of little labels which basically tell us what each input is and pre-designed for. So this one is called the O2 input number 1, which is on ABI 6. And if we pull out our wiring diagram that comes in the ECU box, we can see how this is wired down at the actual ECU connector end. So that'll be cool to go through as well. So I'm just going to go through the loom and pick out all the white labels. These white labels, like I just said, have all the separate functions and what each of those wires does. The beauty of starting with the Haltech premium loom is that we pre-bunch everything together. So for the injectors, all the injector wires are all together. Ignition, they're all bunched together. So you've got a power and you've got all the signal wires. So these are all pretty much pre-laid out. They just turn into a little bit of a spaghetti sometimes during shipping and packaging. So what we're going to do is just go through them spread them all out, and then we can start from a nice, neat base together. So I've gone through and I've separated each of the wiring labels in the loom and just tried to make it as neat as I could. We've got our digital inputs here, which we've set aside. This will be great for a flex fuel sensor, which we're going to run in this car. Digital inputs are also good for some simple switches. So we might do a couple of the steering wheel switches through them. A speed sensor, also really helpful for that sort of stuff. When we go through the ECU pinouts together, this will tell us what we can and cannot wire to very specific digital inputs. One of the most popular questions that we often get through our tech support emails and on the phone is, can I run this sensor through this input? Or will this input allow me to do this or this or this? The best part about the software is it restricts you to running certain sensors on certain inputs. So there aren't really a lot of rules as to what you can or can't run on particular inputs, but the software does go through that very well. So we'll do that later on. Got my fuel pump wire. In this installation, because I know already we've got 2 fuel pumps to run, I'm not going to use the fuel pump wire for the fuel pump. We're going to repurpose this for something else later, but we'll do that later on when we do some mapping. We've got the crank and cam sensor, or trigger and home, as we call it in Haltech. This will go to the cam and crank sensors on the engine. When we set the engine up inside the ECU, so the ECU knows what engine it's going to start, we're going to tell it what trigger pattern this engine has. So that'll help the ECU run this engine for us. We've got a couple of analog voltage inputs here, which I briefly mentioned before for the AVI6. We're going to repurpose 1 and 6 to run our pressure sensors. Because we don't have wideband or O2 inputs that we're going to be wiring in, we're going to use a CAN wideband, the Haltech CAN wideband. So they'll actually plug in externally to any of this wiring harness, which just makes the job really easy. That also gives us a couple of inputs back in our loom to use for something else. So we're going to repurpose them for oil and fuel pressure. We're going to add a fuel pressure sensor onto the fuel reg of this car, and we're going to use the factory oil pressure, which is on this engine. If you wanted to use oil pressure on your engine, you would buy one of the TI or Motorsport sensors for oil pressure from us, and then with that, we give you a guide on which wire goes on what spot on this connector. We're going to do that in the next few episodes together. So that's what they're going to be pre-assigned for in our map. The map sensor is an external map sensor. You've actually got the option on the 2500 to use the internal or the external map sensor. On this car, we're not going to be running a lot of boost pressure for now. Plans always change, but the internal map sensor on the ECU is good for 30 PSI. This engine and this turbo in this setup is not going to be running anywhere near that. So we might actually repurpose this external map sensor for something else fun, maybe like a boost trim switch or anything else. Again, the ECU will tell us exactly what we can and cannot do with this wire and this input. The air temperature and coolant temperature, again, pretty self-explanatory. That will just go one on the inlet and one in the coolant temp. The coolant temp has actually been relocated in this installation to keep it away from the dump pipe and the exhaust heat in this particular application. So you can actually move it to the back. So that's where we're going to move this coolant temp sensor. Wire input to. This input here has been pre-set up for throttle position. So in a cable throttle position, so on an LS1 engine, this would have a predestined input already set up. This is a drive-by-wire application, so we're actually not going to use this input for that specific cable throttle. We're going to use one of the other analog voltage inputs, and we're going to use 2 for the throttle body because that's what the computer needs to run a drive-by-wire throttle. And we're going to use 2 of these inputs for the electronic pedal as well. Each of these pedals and throttle bodies for an electronic drive-by-wire condition, they actually need both. 2 up there and 2 down at the pedal. That's a safety parameter within the ECU itself. We only do this because that's what factory designed. So we're just following how those designs are all done from factory-based applications. We've got a switched 12-volt install wire. This comes from the actual key barrel in the car. You'll notice that when you turn your key on first to accessories, then on or ignition, and then you have a spring starter. This will go to the on or the ignition. This stays on while we're cranking the car, and it does not get wired to the accessories. If you accidentally wire this one to the accessories, you'll crank the car and the ECU will turn off, so your car will never start. So it's important that we're gonna try and find the right place to wire this one as well. So we'll do that with either a multimeter or we'll do it with our power probe, and I'll show you how to use that later on as well. We've got our 8 injector outputs here as well, and the power wire that is already pre-wired through a relay in our fuse box. Just makes the job really, really easy. So there's no mucking around with relays or pre-configuring any of that wiring. That's already done for us in our premium loom. So we've got those, and we just need to figure out which one's injector 1, 2, 3, 4, etc. on the actual engine itself later on. With the Haltech ECU, we always wire it in cylinder order, not firing order. We preset the firing order in the setup page. The LS base map is fantastic for that because it does everything for us already. Likewise, same with the ignition wires. We're going to use our power wire to power all these coils. These are these have got internal modules in the coil. So there's not an external ignition module that we have to wire up for this particular application. LS coils are fantastic for exactly that reason. They're compact, they're actually very, very powerful and can generate a lot of spark energy, and simple to wire as well. All these will require is a ground that will go to the cylinder head, and that we're pretty much done. So that makes it really, really easy. In other applications where you've got a factory coil like a Ford coil, like a Barra coil, or one of the V8 Ford coils, you actually need an external module to then wire up the signals into that module, then back out of that module up to your coils. It's just a whole nother wiring step which just takes time. That module also costs money, so sometimes reusing factory modules that may be or may not be reliable is a tricky one to add into that equation. So it's just more cost. So if you can use an internally modular coil, it does save a lot of time and a lot of money. We've got some outputs pre-assigned for a stepper motor or a idle control motor. We don't have one of these on this car. LS1, however, had a 4-wire stepper motor which actually moves backwards and forwards, and the ECU controls that. That controls the idle speed of the engine. With the drive-by-wire system, we're actually going to do all of the idle control through the drive-by-wire throttle. So we get to use these as anything else that we want in the car. I'm going to pre-wire and assign these as the fuel pump outputs. And we're going to run these to the back of the car and control relays down at the back of the car. The other 2 might be free for something else altogether. So we can either use them for something fun, or we can take them out of the loom altogether, or, because plans always change, I can put these into a connector that's going to be ready if we want to do something in the future. All we need to do is make some pins and another connector on the other side of that later to do something interesting later. More outputs for other interesting things that need to be done on a car. Normally you would need at least a tacho wire. A tacho would control the factory tacho in the dash. Sometimes, depending on what installation we're trying to do, the vehicle speed might need to be controlled as well, so we can take control of that. We've got a boost control solenoid that we need to control the boost on this car with. We might need to control an idle motor, which is not a stepper motor. Subaru were very common, Ford also very common to have a 2 or 3 wire idle speed BAC motor or bypass air control. So not a 4-wire stepper motor. Toyota, Mitsubishi also very, very common to use 4-wire or 6-wire stepper motor. Very common for the Subaru models to have a 2 or 3-wire idle control motor. So we will go through and pre-assign these as to whatever we need when we figure out whatever we need to run this engine. I've got 2 knock sensor inputs, one for the left bank and one for the right bank, or the driver's side or passenger side. We've got the 2 drive-by-wire outputs. These 2 will be joined up with another 2 wires for the analog inputs that go up to the throttle body, a signal ground and a 5-volt. We'll go through that later on, but basically that's what these 2 wires, this is to make the throttle body go rick, rick, and you'll hear the calibration process a little bit later as well. Battery positive, pretty self-explanatory there. This is where the power for the relay box and the ECU all comes from, so this is very important to get this right. Battery ground, also very important. This one, not as self-explanatory. Matt's star grounding video that we did very, very recently will help with where this actually needs to go. So that might be another cool link that we can go to and do some research to figure out why battery grounding is so important in every single ECU installation. Just putting my bed together for the next 2 weeks. As I won't be going home, I'll be intently wiring this car to get it done because I just really want to get it done and out of my life. In here we've got some trans brake buttons because this has got a turbo 400 in it. So we've got some shifter stuff we've got to work out and starter position lockouts so that we don't start the car in gear. So there is a bit of stuff we'll go through. This interior is disgusting, but I'm sure I will be disgusting after 2 weeks in this car. Great. Now that I've actually gone over the entire car and the engine, I'm going through to... What's that? Oh, lunch is... Why are you standing so far away from me? Come on, man. What we can do now is go through each input and function on the actual ECU map and make sure that we've got a wire set up for everything that we actually need and want in the future. We're going to control the starter motor in this particular application through the ECU. So it's as simple as picking starter motor relay output. We want to make sure that we've got an output which is going to do the job, and we're going to pre-assign one of those. Mentioned before we didn't have a stepper motor output, so we actually got these stepper motor output wires freed to use. So I'm going to pick number 3, and that's going to go to my new starter motor relay inside the car. I'll also need a starter input that then also tells me when to switch that relay on, and that will most likely come from the key in this particular car. I'm going to pick this wire here, as I don't have an external map sensor to worry about, and I can worry about how this is all going to work and function later on. Once we've got this I/O report set out in such a way that we can go through each wire, it will make it really, really easy to make this wiring on the bench and then figure it out from there. So I've gone through, finished my nachos, delicious. We've made a wiring schematic of where we actually need to put each wire in this car now. So for instance, we've got the fuel pressure, factory oil pressure, all the coils and injectors, they're all pre-assigned now within Loom. We've got the drive-by-wire sorted out. There's a pedal somewhere in this car. I think it's maybe over there, I'm not really sure. There's a gearbox temperature sensor, and that's going to trigger the trans fan, which is actually at the back underneath the car. We can actually map the fan to turn on against the actual transmission temperature, which is pretty cool. So we're actually going to run 3 thermo fans in this car altogether. We've got a GM style power steering. We're actually going to control that as well through the ECU. Not for any particular reason. It can just be done normally through just a switched 12 volt. But we're actually going to map it against the vehicle speed of this car so that we can try and get the feel for the car as nice as possible. Sometimes when the steering is too light, when we're going too fast, the car doesn't feel right. But if we can turn that off when it gets to a certain speed, maybe the car will feel a bit nicer and handle a little bit nicer. So we can muck around with that and see how we go. Like I mentioned really quickly before, we've got the trans brake and creep buttons. That is something that the owner wants to use for fun because he does want to drag race this thing on a Wednesday night out at Eastern Creek in Sydney. People often have a great time out there, so we've got to wire those parts in as well. We've pretty much used every single wire in our Elite 2500 install. So what I'm going to do is just quickly show you how to go to the View I/O report. So now that we've got all of our wires set out in our ECU map, we're going to go View I/O report. Basically, once we've got this I/O report set out in such a way that we can go through each wire, it will make it really, really easy to make this wiring on the bench and then figure it out from there. So you can see that we've used every single wire except for the crank and cam reluctor sensors. The reluctor sensors we're not actually going to use in this particular cam and crank sensor because they don't have them. It's a Hall effect sensor, so we're going to use positive power and ground to get those sensors to work because they are digital sensors. While somebody who is allowed to go and interact with other people is grabbing my forms off the printer, I'm just going through and just starting to figure out which wires might need to go. Ah, sweet. Thanks for that. Go and wash your hands. Now that we've got our forms, we're going to go through and then we're going to group the wires together in such a way that it actually makes a lot of sense where they're going to go in this particular car. You won't group them exactly how I'm going to group them, but it won't be too dissimilar either. I've just gone through and picked out my drive-by-wire throttle wires, which I've pre-selected in my map. So I've got my TPS1, TPS2. I need a 5 volt and a ground for this particular throttle sensor. And then I've also grabbed the 2 drive-by-wire positive and negative wires, which are pre-assigned in the Haltech mapping for me already. So this bundle is what I've taken, and the colors all match up with what I've already pre-selected. So I might just quickly take these off so I know that these are already done. Now that I've done that, I'll go through sensor by sensor for all the ones that aren't pre-done. So coolant temp, already done for me. Air temp, already done for me. So I'll just go through bit by bit by bit, and then we can go through that at the end. So I've separated the bulk of our harness into the different areas of the car that they're actually going to go. So this big bunch here is our main bunch, which is going to go through the firewall grommet once I've done a little bit more work. This will go in and what we're most likely going to do is put it through somewhere near the trans tunnel on this particular car. A very, very common place for the loom to go through is a firewall, either on the left or the right hand side, depending on the orientation of where the driver is, or whether it's a race car or a street car. Because we've actually got lots of room in this engine bay and it's all been nicely painted at the back, we're going to keep it away from the dump pipe, we're going to keep it away from the driver's feet and his controls, and we're actually going to put it through the trans tunnel. There is just so much room there, we may as well take advantage of it, and it's all out of the way from heat, fuel lines, and just all the other stuff that is involved with running an engine. Next, I've got the fuel pressure and the flex fuel sensor. They're sort of grouped separately and together because in this particular car, the fuel reg and the pressure sensor are right over the other side, and I don't want the dump pipe to be anywhere near my wiring. It just makes it a lot easier to keep it away from the heat, and we'll actually route that from the inside through the fender, hopefully through, and just make it a little bit more neat. So I'm actually going to do a bit more research about the routing of these particular wires first before I commit to doing anything else with these wires and going ahead and getting it in the car. Next group I've got are going to go across the inside, along the inside of the dash and across to the driver's side. So in there I've actually got a bump button, the creep button, or the bump and creep button, so we can actually change how we're actually going to use either of those inputs. The trans brake button, we're going to do the starter through the actual ECU control as well, so that makes it really, really modern and nice to just maybe have a key just where you tap the key and it cranks by itself. So the ECU has smarts to do that. We're going to probably put a button in this car. This is the second time I've wired this car now, but the first time doing it for EFI. We did have a few problems with the actual ignition key barrel before, so to rule out any problems that we're going to have anymore, I'm just going to probably put a start button in and around the center console, so we'll still get the key for security to on, and then we'll press the starter button. So the ECU will do all of that control. So we'll set that up later and we'll show you how to wire that up later. Next, I've got the pedal. So this will be the GM pedal that we're going to install on this. I think it's from a VE model, but I'm not exactly sure. There is a few different connectors that I've seen for different models of car. We'll go through that and how to wire that one up. That's going to be a fairly simple process. 4 wires that get split into 6 because we split the 5 volt up twice and the ground up twice. So we'll do that together later as well. I'm not sure what to do about this next group of wires yet, but again, we'll do some more planning and figure out where they're actually going to go in the car. These are going to run to the rear of the car. Like I said before, we were not going to use the designated fuel pump system inside the loom. Instead, I'm going to use the fuel pump output wire for the starter motor instead. That wiring's already been done for me within the actual fuse box. So I'm actually going to run a fuel pump output to the rear of the car and set up a new fuse box in the back of the car. The fan that is going to run on the transmission cooler, I'm actually going to run that to the rear of the car as well and control a relay back there as well. And another relay I'm going to set up for the power steering. This has got electronic power steering installed in it. None of the lines are run yet, but it's in its rough position where it's actually going to go. We're going to control the power steering in this so we can map it against an input or an output or the speed in the car. Next I've got 2 thermofan outputs as well. Don't know where these relays are going to go yet, but again, we'll do some more research before we figure out where we're going to route these, but these will be very, very essential because of the giant fans that this car has on it. These are from a late model Ford, and they do use a bit of power. So we've got to strategically figure out where we're going to run them and how we're going to run them, and then we'll go from there. So in the car, like we were just talking about, I'm going to try and route the boost control solenoid through the fender here, just to try and keep it away from all the heat of this dump pipe that I was talking about before. So we've got to protect the wiring, so we're going to try and run it maybe underneath here. And there may be some other body wiring that may need to come through here at some point in time, because the owner has requested that we take all of the wiring that used to come sort of in and through here and all that sort of space. We want to try and keep it nice and clean and neat now. Fuel pressure and the flex fuel sensor, might try and figure out a sneaky way of running it through there, or maybe through this part of the inner guard, just to try and make it nice and neat. There are nice grommet solutions which we might be able to use, which are nice and neat. And again, just heat. We're trying to keep everything away from the heat. There are different ways that we can protect the wires from the heat, but we can definitely try and figure out the best solution for this type of installation. That's about it for today. I've got a bit more planning on the bench to get done. Definitely more planning, because the more planning, the neater the job in the end. If you find yourself getting a little bit tired, if you find yourself getting frustrated at what you're doing, it's always a good idea to just stop. Wiring is not something good to do when you're tired, and making mistakes is not good, because finding them later is very, very difficult. So I'm going to call it for today, and I'll get back onto this tomorrow. Have a good night, everyone. See you for another day of isolation tomorrow. So today we're actually going to add some wires into our integrated fuse box in the Haltech premium loom. What we're going to do is add in 2 extra relays that are going to work for our thermofan controls. So we're actually supplied the extra fuse and relay pins, and we're going to add in our 2 thermofan relays here. So I'm just going to go through how we're going to incorporate these and how they're all going to work in the system together. So in our little fuse box here, these are where the fuses live, across here. And then we've got our fuel pump relay. I only know this because of our wiring diagram that actually comes with it. It actually specifies which coloured wires are what they're actually doing. So we've got our ECU fuse over here, the injection and power supply for the ECU here. So this is the power supply and the relay for the ignition coils. And then what this one is the fuel pump. Like I said in one of the previous videos, I'm actually going to run the fuel pumps all the way in the back of the car. So I'm not going to run this powered wire. It's probably going to be about 5 or 6 meters all the way to the back of the car. Instead, I'm going to run a new trigger wire from the ECU connectors here to the back of the car. And I'm going to use this wire instead to do our starter motor. We did have a few problems with the ignition barrel on the car. So what we're actually going to do is use this one instead to do the starter through a button. So I'm just going to break apart the cable tie and braid and grommet, and we're going to try and feed the wires back through the braid that goes to this fuse box here. And we're going to just try and do that as neatly as possible. I've pre-run a couple of lengths for the thermofan and made a note of it on my document. I'll show you the document and what changes I do to that document, just so we can keep a very good note of what wires we have used and what colours they are and where they're going to go. So I've roughed in some wires, but yeah, basically we'll just go through and we'll add these in now. So I'm not having a good time feeding this through because I didn't think and I wasn't planning well enough. I often find just wrapping a bit of electrical tape around these wires does actually help to try and feed it through and pull it through really nicely. So let's just do that. So now we've got our wires through at the other end. Just going to untape them all again, And then we're going to go through the pinout of a relay and select the correct relays for the job that we're actually going to do. It's very, very important to just not pick whatever relay is lying around on the ground. You will run into problems often, and I do see this quite often with some of the phone calls that we get. These two relays here look exactly the same. Apart from not having a tab on one, they are both Bosch relays, and they're both black and they're both square, and they've got a very, very similar part number and same footprint layout. They look almost identical. This one's got an extra pin in the middle because these 87 pins are joined together. But if you actually have a bit of a better look, you'll actually find that this one is 30 and this one is 86. This pin here is 30 on this relay and this pin here is 86. These two relays are completely different in the way that they actually work together. This is often called a changeover relay, which can give you some very undesirable side effects when you actually put in the wrong relay. So make sure you check what footprint the relay actually has and what its function is actually supposed to be. We ordered 2 of the brown Haltech relays, which are the same as the other ones that actually come in the fuse box. These are 30 amp relays. These fans that are in this Falcon are actually ginormous, and they're very, very known for drawing a lot of power. So we're actually going to put 30 amp relays in them. We're actually going to stage the fans on 2 separate outputs so that we can run one, so it'll turn on first, and then when it actually gets really, really warm, we'll turn the other one on. So both will be running at full ball to try and cool the fan, cool the cooling system as much as possible. And then when they drop below a certain temperature threshold, they'll turn off again. So we'll set them up a little bit later. In this particular car, the battery has been relocated to the rear of the car. So I'm actually going to use the stud that is on the starter motor. That is going to be our main battery supply because we have run a big, thick battery power from the battery down under the car all out to the starter motor. So that's going to be our new battery post. There are a number of different ways to do battery positives. These studs are quite a really handy way of doing that as well. I just buy these off eBay. They're very, very cool. I also get the little caps off eBay as well, which is just a nice, neat way of securing and keeping those power studs away from a stray screwdriver or something else that you might be doing up that then might arc off to the positives post. These are great, so you can get ones that go through the firewall as well, so that might be another option for us as well. If we link off the starter motor and then come up to here, and then if it went through the firewall, we could then put on the other side of this wire and latch that onto the back of the post here. But because this is going to be relatively simple and we're going to keep all of our power in the one fuse box for this particular install, we're just going to run it through the loom and snake it through and then put that on the starter motor positive, and that's going to be our main battery supply. Not the alternator. The alternator can be a little bit noisy and can create some very undesirable voltage noise. The battery or the starter is going to be a bit of a bigger sponge for that noise, so that's why we're going to put it there. The alternator is also a little bit harder to get to and it's further away, so starter motor it is. So we're going to crimp some pins onto these wires, and then I'll show you where we're going to put them in relation to what slots and what relays they need to go into. So we've crimped on our pins to the ends of our positives. The thermo fan outputs themselves, the trigger wires that are going to trigger the relay, These are going to go straight from the ECU output here. They loop up and loop neatly down into the fuse box. So that's what we're going to use to turn the relays on. Thankfully, we've got our switched 12 volts already done for us. These are all pre-done in the fuse box, relay fuse box that comes from Haltech. So that saves us a couple of pin crimps, which is great. We don't have to think about which side of the relay we need to trigger on that because they're already done for us. So naturally, these will go on the other side, which is fantastic. So we'll quickly go through and then pin those. I've got the other side of our fuse, which is going to protect the circuit for the power side of the relay. They're going to go in here, and then we're going to loop those around the fuse box and then populate the bottom 2 pins, which is pin 30, so that 87 can then go trigger out to the actual thermofan itself. So with this one, we can see that we've got our positive in and positive in to go out to the fan. This is one of our relay trigger wires. So this is what I was talking about. This will be the other side of the relay. So positive over here, and this will be the negative. And put that one in there. I don't know if you can see right down there, but that wire, which is the black with a red stripe, the crimps are actually facing that way. Ours are facing that way. So I know that I have it backwards. So all I want to do is pick that one up, turn it around, push that in. This is a thinner wire because this is just a very low current trigger wire that comes from the ECU. So I just need to push that down the best that I can. Sometimes I need to use a little poker to try and push that down. And that's that click that we were talking about and looking for before. So now that we've got a nice flush clicked in relay pin, we'll do the other one. Remembering that we need to have the pins facing that way. This is very hard to do with one hand, actually. And that's seated that pin in there beautifully now. So all we're missing now is the bottom pin, which is going to be for the positive supply, which I've got here. So that'll be the next ones to do. So now that we've got our pins crimped on nice and tightly, made a mistake on that one. I've absolutely butchered. I'm only human after all. So lucky we get a couple of spare pins in the pack, so we'll definitely keep that one aside for a rainy day when we need to do another fuse box one day. Maybe we've lost all our pins or we damaged 3 pins on the next one. So definitely keep this one in your toolbox or in a plastic container. I'll show you my plastic containers later on, full of empty pin, full of like random and assortment of pins that have always come through when I needed one at the racetrack, or somebody damaged one doing an install and they're like, oh, I don't have another one, and everything's closed because it's Christmas Day. So they're always, that's when that'll come through and be really, really handy, and you'll be the hero. Now we've got a fully populated relay base for us to click in our new fan relay and another fan relay. We're going to put in 2 30 amp fuses here. I know that these fans are going to take a bit of juice to run, so 30 amps will then cover that. We can definitely try a 25 amp fuse in either, and we'll just have to monitor those if we need to just check. 30 will probably be right for these though. The way to check that is to put in 2 25 amp fuses. When the fan turns on and runs for about 30 seconds, if either of those fans blow, we know it was probably just the wrong size fuse. 30 will cover that little bit of headroom that we might need for any temperature changes or wiring issues that we might have, because the ground on the other side of the fan will also affect how much current that this needs. So I've just run down to my local automotive parts supplier and grabbed some 30 amp fuses. I definitely did not take them out of somebody's car in the car park here. They may find that out the hard way when they try and go home. That's fine. Never take fuses out of your own car, always somebody else's car. We have now got a fully populated relay and fuse box, which we don't have to think about anymore. We just have to remember which wires we've assigned. But the best part about that is that a sheet of paper has already done it for us because we've already decided which wires we're going to use. So we don't have to go and think about it and remember. We've already done it. So that's probably a very, very important part of the process. Remember before I was talking about a wiring schematic? Here I've just used a little bit of wire which I chopped out of my power supply wire to go to the fuses. I just know that that is now what the fan supplies are using. The power that I'm going to use for the trans brake is this thin red wire, and the trans brake output from the solid state relay is this thick orange wire. So I'll keep adding to these, and then we'll make a pretty good library of what wires are actually in this loom. It's all documented then for the new owner of this loom. There's nothing worse than taking phone calls at 1 AM going, oh, hey, do you know where this wire goes? Or do you know where this wire goes? Because I'm stuck in the middle of somewhere and my car doesn't start, or something's broken, or I just don't know how to troubleshoot it. So if we can make it as easy for the owner as possible, this is how to do it.
Hey buddy, how you going?
Good. How you going, man?
Good.
Excellent.
When you got your lunch?
Oh, dude.
Disinfect it before you open everything.
Yeah, well, I'm definitely going to go wash my hands.
Man, the weirdest thing happened.
Yeah.
I went to start my car to go and pick up lunch. Wouldn't go.
Huh.
Weird. Pulled apart, took me ages, pulled everything apart, and then just went to the fuse box. Ignition fuse missing.
Really?
Yeah.
Huh. So I just got word from the marketing guys who just called me from bed. They're all still in bed, working on their laptops, but they're in bed. That the episodes are going a little bit too long, so we'll probably have to wrap this one up today. It was really good going through this part, but tomorrow we'll have a few other hacks and quick tips that might be a little bit helpful when you're trying to wire up your car. So that'll be all for today, but I'll see you again tomorrow. Ugh, a miserable day outside. Good day to stay inside to do some wiring. So next I'm going to give you a really quick Dave wideband hack. Basically this is going to be a really quick way to not have to use the little breakout that comes in the actual wideband box that we supply you. We supply this little breakout loom for all the other installs that might need to get done, which is not using an Elite harness. I'm going to show you a really quick way of how to use the standard plug and not have to use this breakout plug, which just makes the whole job a little bit neat. I am having to yell at the moment, sorry, because it is raining. It doesn't rain all that often around here at the moment, but it's here and we are loving the amount of rain that's coming through, but that's why I'm having to yell at the moment, so sorry about that. In the instructions that comes with the wideband, we are not able to plug this directly in and power up our wideband. The reason for that is because the signal ground that is in this connector is not designed to power up an auxiliary unit. It will power up things like the dash, the IC7 dash when you plug it in, but it's not really designed for the heater circuit that is in the wideband. So what we're going to do is find where this wire joins to all the other signal ground wires in this loom. We're going to chop it away from that and we're going to join it onto the power ground instead, which is going to be grounding to the battery negative or the engine block, which are joined together on the engine block anyway. So that's what we're going to do right now. So I've cut the cable ties off the braid, and what we're going to try and do is trace back this signal ground wire that goes to this CAN connector and find out where it is up here. So let's do that now. So I often find just trying to pull on that particular wire sometimes helps us find it up here a bit easier. So we can see that this section of loom started moving. So it could be one of these 2 or 3 looms, wires that I'm trying to find. We're getting closer and closer and closer. So I have a feeling it might be this one. So if it is this one, this wire should go back down, which it is. And I'm pretty confident now that I've got the right wire. Now that I've got that wire, I'm just going to quickly identify it. Because when I pull this grommet back over this loom, I'm going to lose it again. Got my identifier, found it, and I can see that it joins in right up here. So what I want to do is isolate that particular wire away from this bunch as close to the heat shrink as possible. Make sure I got the right one with the identifier, and then I'm just going to make sure that this can't possibly arc out on anything else in the loom by just taping it off again with some good quality tester tape. Now, what I want to do is find the power ground, which is a black wire in this loom according to our wiring diagram, and we're going to use one of our little joins to splice into that power ground so that the power source for the connector is good enough to power our wideband. So I found the black wire. Now if I wasn't 100% confident with what I was doing, I'd probably put a little nick in this wire up here. I'd then make sure I've got the right ground wire in our ECU connector and follow that ground wire to wherever I have it running in the loom and make sure that the end is also this wire, just to be 100% sure. I am 100% sure that I've got the right wire, so we're going to go ahead and then just splice this wire in to our power ground here. So I'm just going to cut back a little bit of wire and then make sure that we can run it across safely and neatly and splice it into one of our ground wires over here. So give the wires a little bit of a twist to stop them fraying and going all over the place. It's nothing worse than having one random strand of wire that could be shorting on something that you didn't pay enough attention to. Just going to cut that down to a nice, neat length. And then we'll grab one of our small brass or copper crimps and then we'll cut one of those off. Place that like that. All right, so we've got a tiny little crimp. I get these delivered to me from RS Components. They're an electrical supplier in Sydney, where we are. They deliver all over the world. RS Components have a whole bunch of these little crimps. I will put a link up in a couple of the videos that show you the exact name and part number of these. And these, I saw a lot of people talking on Benny's IS200 wire up, where he got a lot of his little butt terminal joins from. RS Components will probably be one of the best places to get these from. So basically we're going to lay both of those strands next to each other in the same area. We don't need to twist them together, because this is going to do all the work of joining these wires and crimping them all together to get a nice signal spliced in. So we're going to crimp it on the biggest setting first, and then we'll go one down from that, and I would be pretty confident with that splice that that is definitely not going to pull apart. So now we've got our CAN power, which is down here, spliced into the battery ground, sorry. I'm going to use a good quality electrical tape to protect that circuit. couple of layers so nothing can pierce through with a strain of wire. Now we've satisfied the instructions of the wideband, so we don't actually need this. So we could use these power and grounds for something else in the loom, and you get 2 free Deutsch connectors. Very, very handy. So I'm going to pack all this stuff away for now because we won't need it until we start getting stuff back in the car. But basically we've done our CAN wiring, so we can run our little CAN hub now straight out of this, and our wideband, our dash, and any other CAN devices that we might want to use later, we definitely can. So that was just a quick little hack to show you how I do the CAN wiring. I've quickly isolated the outputs and a switched 12 volt that I want to run to the back of the car. These were going to be, one is for the fuel pump, one is going to be for the transmission cooling fan, for the cooler that's actually mounted underneath the car. And there's going to be another one which we're going to trigger the power steering motor off. There is a couple of different ways that we could do this part of the loom. I could simply use what I've got here, put all these together at the end, which is a nice, neat ending for these wires. And then I could do one of two things. I could use 4 of these crimps, and then I could expand and lengthen the wires that are coming off here and going all the way down to the boot. That would then probably break up the coloring, which could make it tricky to diagnose something in the back of the car when it's pinned out differently up here to here, and then from here we've got a few different colors, so that could make it a little bit tricky. Option 2 is we could put a nice neat connector, which is a 4-pin connector, just like the one we saved from our wideband. We could then pin a nice low profile connector, put another 4-pin connector, and then again join the wires with a nice neat connector. That does give you the option to pull them apart if you ever need to in the car when you're feeding things through the car. Or what I am going to do, because it's only going to help me later on trying to diagnose things if there's ever a problem, I'm actually going to run 4 new lengths of wire, which I've measured up beside the car so I know that they're long enough. And I've just made a quick rough diagram on my cheat sheet to say that this one's going to be blue, this one's going to be purple, and this one's going to be green, and this one's going to be red. So what I'm going to do is crimp some ECU pins directly onto these wires. I'm going to de-pin where these wires are going in the loom, and then we're going to have some brand new fresh wires that are going to trigger our relays down in the back of the car. So let's do that now. So we're just going to crimp on our new pins to our new trigger wires. Basically I've cut just enough away that it's going to be about right to place directly into the pin. So you can see that the crimps there are going to clamp onto the wire strands themselves, and then the strain relief at the back is going to clamp onto the insulation itself. So give them a quick twist. And now they're all nice and neat with no rogue strands. Place that in there so that the wire will only be clamped onto this part. It's amazing how many times we see people clamp the actual PVC into this part, and guess what? That output or that input no longer works because there is no continuity with these strands of wire. Let's give it another quick twist just to make it nice and neat, and now we're ready to crimp onto these pins. Going to use our ECU wire crimpers. and we're going to use E. E is the smallest die that we have on this particular crimper, and it works absolutely perfect for all the ECU pins. So you hear a nice little snap, and that is crimped beautifully. You could probably hang off that now and it wouldn't have a problem. I like to go with either C or B. Probably just depends on the thickness of the wire that you're happening to use at the time. This one's probably a little bit small, and you can see that it deformed that crimp just a little bit. So A or B probably would have been a better option, as it now kept that profile nice and small. We'll do a bit of a better job on the next one. So E again, wait for that nice snap. Crimps down and pulls right down in on those wires. And then we'll use A like we talked about before. As you can see, A doesn't do nearly enough to crimp down on that particular wire. Hopefully B brings it home just where we need it. So it's nice and straight, and that'll go straight into this plug, just like all the other pins have been done. Now we're ready to go find where these 3 wires need to go in the ECU connector to replace these ones. So I'm going to start with the first output that we need to go through, and I can see that number 1 is blue. That's the Thermofan 3, which in my notes I know is my transmission cooling fan. So I want to take the blue wire first. And I want to feed the blue wire in through under the braid, and I know that that needs to replace pin A1. That is really, really easy for us, because I know that A is the bigger connector according to my wiring diagram. B is the smaller connector according to my wiring diagram. They've got different amount of pins on them. A1, if we look on the back of the connector, we can see is the very, very top left pin, and the colors even correspond down at this end, so I know that that's the right wire. Again, we can check that with a multimeter if we're not sure. We're going to simply de-pin that connector by pushing the lock. You can hear the nice snap that comes from that connector lock. Once you've got your 2 little rabbit ears poking up the top, that basically means this entire connector is now unlocked. You need to be a little bit careful, because all of these pins are now free. If you pull out one a little bit and another one might move ever so slightly, it's going to be impossible to lock this tab back down again. So we're going to make sure all these pins stay nice and flush at the end of this connector. Otherwise it can be a bit of a nightmare trying to get it back down together, getting 34 wires all pushed up nice and neatly. So just be a little bit careful when we're doing this. We cut the cable tie off it. And for now, all I want to do is de-pin A1. It's that simple. Now that I've got that one de-pinned, it's always a good practice to push those 2 little rabbit ears back so that all those pins are locked again. There's nothing worse than trying to fix all 34 pins at the same time. This is probably a bit better so we can see. A1 just goes down and pushes nice and gently, and that's it. That's now seated. All of them are in there. I can see the pins. They're all seated in the end of the connector. So all I need to do is push those 2 locking tabs, and it's that easy. I'll show you what it looks like when you've got this pin not seated all the way down to where it should. It might feel like that's as far as it wants to go when it meets a little bit of resistance, but you can see I can't push these tabs down. They just won't push in, and that's because the pin is actually seated in the wrong place of that connector. Push it just a little bit further and they snap down. That's where that pin wants to be, and that's where that connector wants all 4 of those pins to be in their positioning. So now that's all done, I can pull the braid back down and throw a nice little cable tie to secure the braid for now. And that's all nice and neat. So there is one more wire that we need to organize, which is the switched 12 volt wire. I've already made a note, which is going to be red. That's going to be a switched 12 volt, which I'm going to splice into my injector power circuit. I can either do that down here, but going through all of that again is not going to be that much fun. So what I'm going to do instead is just use the wire that I can see here, which is A26, which is red with a blue stripe, which is exactly the wire that we're going to try and splice into. So again, we're going to use our little brass or copper butt crimps, and we're just going to do that down here somewhere nice and neat, out of the way, not on a corner because corners don't play nice. So somewhere a little bit further down here, and we'll crimp those together, and then we'll run some braid with these 4 wires that will go all the way to the back of the car. So you heard me talk about wire braid before. This is the wire braid that I'm talking about. This is really, really handy for doing some simple wire coverings, particularly over lengths. I find that this stuff is great. So this is going to be obviously used for a much thicker length and bunch of wires, right up from probably anywhere between 10 to 20, 30 pairs of bits of wire. They're all going to go on something this big. The next one down will be something from anywhere from 4 or 5 bits of wire up to probably about 10 or 12. That's when this starts running out of stretch. And then the little bitty baby one is anywhere for 1 through to about 4. 4 is about where you want to stop with this one, depending on your wire thickness, obviously. So this is what we're going to use to run our 4 tiny little strands of trigger wire all the way down to the back of the car. So we're going to measure that up really, really quickly. So that should be enough. And then I'll take probably just another 20 to 30 centimeters just to be sure. And that should give me enough length. Tricky thing with this stuff is that when you've cut the ends, it then starts to unravel itself. This can be really, really tricky and really horrible because it just, once you start pulling the wires through there, it all starts getting really, really messy and gross. So give it a nice, clean, fresh cut across the top. And I like to use my little micro blowtorch just to give it a nice sealed end. So now whatever we do to that end, they will stay together and stuck together and nice and neat, and you can make a nice heat shrunk ending over that. So I'm just going to cut all of these down to about the right length together, and then let's throw a bit of tape around all 4 wires so that makes it a bit easier to pull through when we're feeding it. Basically, we're just going to feed it in, and I'm always going to stay with the end of the wire. The end of the wire is what we're going to sort of slowly feed over bit by bit. You see, we just keep slowly feeding it down, and I know where the end of the wire is because I can feel it. Not there, but there it is there. So I just keep slowly feeding it. Who had these beers? Alright, we're there. So now, we're right at the end where we need to be. And I'll slowly just leave a bit of slack in this. If you make this really, really, really tight, it tends to not be nice and fluid and uniform. It actually gets really rigid and stuck in its form. But if you leave a bit of slack over the top of this, it makes it really, it makes it a bit more, makes it less rigid and easier to move around. This helps with navigating it through the car as well. So I'm not going to pull it as tight as I can, but that should now get me to the back of the car. It's going to quickly throw some tape over the end of this so that it stays in the right place, and this isn't going to stay here forever because I'm going to put some heat shrink on it when I'm done. But what I want to do is just quickly slide this back under this engine grommet. You've seen me move this backwards and forwards about 12 times now, feeding things in and out. The reason I haven't figured out where this is going to go yet is because when I put this into the car to do its first measure up and figure out where the ECU is going to probably sit in the car, I'm going to figure out where the hole we're going to need to drill so that this grommet can sit nice and neatly in its right place. So I haven't quite figured that out yet, but I know that these need to go to the back of the car, but I'm going to do that inside the car. So running this out with the main engine loom and then back under the car, it's probably not the right environment for these wires. They don't need to be sitting underneath the car getting covered in water and oil and dirt and getting hit with rocks. So we'll probably just keep these nice and safe inside the car. Just going to feed these back through and under this grommet with heat shrink. Probably a good time to also talk about firewall connectors. These things are really, really cool and really handy, and do a very good job of breaking this harness out so that you can have an interior and an exterior harness. So normally this goes through the firewall, and then you actually have a nut and a flange, which I do have around here somewhere. So then this nut actually secures this plug into the firewall itself with the right size hole, and then this one stays on the engine loom that's actually attached to the engine. So this is perfect for a race car or something that may need a little bit more maintenance as far as engines. So you may want to take your loom off your engine to get your valve covers off so you can keep doing adjustments to your lifters, or you may need to do some other adjustments as far as the head or the block or just general maintenance for a race car. This is really, really handy for that. So this stays in the block on the firewall. You unscrew your engine loom and then the engine actually comes out with it. We are not going to use one of these in this particular application, but I have used plenty of these in race car applications. This comes as a really great kit from ALS Connector. We will have a link for where to buy these from. They have a great eBay store, but you can also set up an account on their website. And they've got an amazing array of Deutsch connector and different applications for DT, DTM and DTP sized pins that carry all sorts of different currents. They've got these really cool little rubber boots as well. So you've probably seen on all the crazy Instagram stories that people put up with their amazing wiring harnesses that they've always got like a heat shrunk boot over the end. Really, really good unless you might need to make a change. Because this is an enthusiast level sort of wiring, I like to use these little rubber boots instead because I often like to change, innovate, always add or remove a sensor, a solenoid, something in the future. These are always great because you can always pull them back, slide them back down your wiring harness and feed in the extra wires that you may want to put through without ruining your $50 to $70 heat shrink boot that you have to cut off. Deep in the whole thing, repin the whole thing and then put on a new boot when you're done. So these are really, really handy and do make a really nice, neat install when you're done. Just doing a little bit of a neaten up. Things just got a little bit crazy and wires started branching off in all sorts of different places. So I'm just doing a really quick cleanup of my workspace and my work area. Can you be gentle with my package? Somebody already opened it. This is my stuff from EFI Hardware. I ordered these GM connectors online from them the other day. So when I was chilling in bed, I went through and looked at their EFI plugs and found the GM section and went through and just basically just added to cart really quickly everything that I might need to wire up on this engine. So I grabbed, by the looks of it, a couple of knock sensor plugs. So I asked the owner if he could bring the knock sensors down, as he didn't actually have them on the car. So we got the knock sensors, but no plugs to actually go on them. We could go through and cut off the ones from an original loom and then solder the wires or use all the crimps and then have a crimp that joins to another crimp, but it's kind of nice if we can use the new plugs. It does make it look really nice if you can use all brand new plugs. They are definitely available for most makes and models, so go to their website and have a look. It's really easy to navigate around, but look at that, brand new EFI plug that suits the knock sensor. I got one for the alternator as well, because we're going to try and control the voltage on the alternator. The VE alternator actually has a controller in it, so we can actually move that up and down and control the voltage, so we can control the load on the engine when it needs it and when it doesn't need it. I've got a new crank sensor plug, cam sensor plug, so that we can get brand new connections that are not broken anywhere between the actual sensor all the way up to the actual ECU. Just be one continuous wire, which then troubleshoots so many problems out the door, because we don't even have to talk about there being a broken wire anymore. I got a brand new set of injector plugs as well to suit the injectors that the owner has already put in the car. So that'll make it really nice and neat and easy. Not flexible. Well, that was a long day of wiring. Can be quite a tedious and a long process getting an entire car wired, so it does take a long time to do it nicely and neatly. It is very underestimated sometimes how long it actually does take. I'm actually stopping and doing all the tedious, really boring parts that happen again and again, just to stop boring you with them. So I'm just going to kick back and get a lot of rest tonight, listen to the beautiful tones of the rain falling on the roof, and we actually found some very appropriate technology for the age of this car. So I'm going to kick back with a bit of Enya and yeah, hopefully get some good rest tonight. Hey guys, so today's adventure, we're going to just triple check that all of the power and grounds and 5 volts that I need are actually supplied up this end of the loom, just to make sure that I'm not missing anything or I'm not going to leave myself short when we start putting this in the engine bay. So I just want to make sure this is all properly assigned. Once I've done that, we're going to drill a big hole and hope that it is in the right spot. I'm just going to quickly go through this loom and just make sure I've mentally checked off that I've got a power and a ground and the 5 volt clearly earmarked for every sensor wire that I've got. It just helps me sleep better at night when I know that I've got this all planned out better. And when you're sleeping in a car, every minute of sleep that you can get definitely counts. So for this one, for example, I can see that this is my fuel pressure input. So I'm just going to make sure I've got at least a 5 volt and a signal ground. When we actually look at the fuel sensor plug and the wiring, it'll say that we actually need at least a 5-volt power and a ground and the signal. So these make up the 3 pins on the fuel pressure sensor. In that same area of the car, I'm also running a flex fuel sensor. So I've got my signal wire here, and I've got a ground for this one as well. But this flex sensor actually uses a switched 12 volt from the ECU. So if it used a 5 volt, I could probably just share this 5 volt wire, but I'm actually going to run a separate 12 volt. So that's why I've planned and got that done. It'd be nothing worse than getting to that part in the car and going, oh, now I need a 12 volt wire, and then having to run it all the way back through. So planning is key. So we're in the cockpit. We're in the passenger seat, and we're going to try and find a nice place to drill a hole for the loom to go through. Got my trusty torch, so we're going to try and light up the area and just get all this stuff out of here. So I'll go get a box and get rid of all this stuff. We'll pull the carpet back because the owner has told me that he wants to replace it anyway. So we're just going to pull it all back as much as we can, so that we can get up to the tunnel. We're going to try and put it through the tunnel. It's kind of out of the way inside the car, and also outside it's also going to be not presented and hidden pretty nicely. So we're just going to try and find a nice place for that to go. I might use a little test hole and see if it's going to clear the transmission itself in this particular application. There is a lot of room under the tunnel because the tunnel is gigantic, but the gearbox is actually kind of small. So that's where we're going to try and aim for this hole to go. So let's give it a go. We've pulled all the carpet out. I've found what I think is a pretty good spot, sort of up here on the firewall. So what we're probably going to do is do a little test hole, really quick, with a very small drill bit. And I just want to see if we're going to have enough clearance around where that's going to be. There's no point in just drilling a giant hole because you can't just put that metal back in very easily. So going to measure, double check it, measure it again, double check it, and then we'll see if we can make it work. So this is my little spot under here. So I'm thinking somewhere around here. I'll get a marker and just triple check that. But why I want to do that is that the loom can then run sort of along here somewhere, or it might run up maybe this way, but most likely it's going to go across the back here and up, and then maybe the ECU will be mounted somewhere in this sort of area, but the owner has expressed that it might go up in the glove box as well. So as long as I can get it in this sort of general area, we may even mount it on this floor panel and then make a fake or another floor over the top of that. That's another common way that it is done as well. Not a lot of room in this because of this giant heater and air conditioning box. So this has probably got to stay in this car. So we've just got to work around it. So I'm going to measure up really quickly and just make sure that where we're going to drill our little test hole is going to work for us on the other side. Because when we go out and have a look on the other side, that hole's sort of going to come out down around there somewhere. So we're just going to make sure that hole where we think it's going to come out is actually going to come out here in exactly the right place. So we are going to get a slight issue there because I can't obviously get my drill in there with this tiny little drill bit. So obviously having a hole saw is not going to be an easy job either. So I may need to revise where that hole actually goes simply because of packaging. So may just have to try and go a little bit lower. A tiny little test hole, we'll just see how that goes. Now I'll go out in the engine bay. I don't know if you can see it on the GoPro. There's a tiny little light coming through from all the lights inside the car. That's where it is going to have to come through. I don't have any other room to do it. So we're going to get the hole saw out and put that on the drill, and we're going to commit and get it done. Let's change this one over on the mighty Makita. And we will make a hole. Having a test hole gives us a nice position for this to just go into so it doesn't wander around too much. Ow. This doesn't wander all over the place when we're trying to do it. Ends up a little bit messy otherwise. So let's give it a go. So we're just going to do a really quick trial test just to run these wires through and see how it's all going to fit. Cross your fingers. Now I could have taken out the entire dash of this car to get a better position to drill this hole, but nobody actually wants to do that. We all know that a car is never the same. As soon as you pull out this dash, there'll be a squeak, there'll be a rattle, and you'll never be able to find it again. It's just not worth it sometimes. So I've separated the loom. So we've got our inside component. So this will do the accelerator pedal, our ignition switch, and all the other stuff inside. I've got my other component of the loom, which is going to do the flex fuel sensor and the fuel pressure sensor, which is over this side of the car. And I've got the stuff that's going outside, and our grommet has been moved up to where it's probably going to mount in this hole. So as you can see, that's a really quick test fit just to make sure that this grommet's going to be in place. The loom is moving freely in and out of this loom to get some positioning. Sometimes I like to squirt a little bit of tire shine or actual silicone spray, which is pretty much the same thing, just in and around this area to get some good pen. It just makes the loom slide in and out a bit nicer. Just gonna spray that up a little bit, and then see how much easier the loom goes in and out now. So much better. So now that I've run the loom through, what I'm just going to do very, very quickly is just throw a cable tie and tape really, really quickly just around the inside of that that grommet, just so that the loom doesn't slide backwards and forwards anymore. Once we start cutting things to length, I don't want them moving backwards and forwards and then changing on me, so that the coils are set at one length, but then the injectors are at another length when the loom slides backwards and forwards. So we're just going to try and make that as secure as possible for now, and we'll start measuring and cutting things to length. I've got the loom fed through the hole in the firewall tunnel. We're going to pull that back up through and then separate everything as we need to. So we're going to separate the ignition coils, the injectors. I've got the thermo fans running through here as well, so we'll sneak them down through the engine some way. The alternator is relocated on this particular application, so we're going to feed all of that cabling through and split it up where we need to. So I've run and allocated all of my wiring to its various places around the engine bay. I've got the ignition coils. Going to be a little bit tricky in this car just to measure them up and get them absolutely right with the positioning just because of where they are, but we may just measure them and see if we can make a rough dimensions and make the rough plugs go in about the right sort of place. We might do that on the bench just with a tape measure or a ruler. I've got my injectors split across the banks, coils like I spoke about. I've got my coolant temp, which is actually being relocated to the back just to get the coolant temp away from all the heat that's happening up here. So that's been relocated. Probably another great reason why we haven't used a pre-terminated LS loom in this application, just because the stuff is all over the place and it's all in different geometry as to what the factory loom is set out to be. So we are going to start cutting. I've got my injectors, which are going to be cut down to length. Once I've got them in their right sort of lengths, I'll be able to then take this back out and then neaten it all and add in all my extra power wires for my injectors. I'll do all that on the bench because my old man back is not going to cope very well for much longer reaching over this gigantic engine bay. So I've just done a really quick measure and cut and left a little bit of extra length on there just so we can get the plug on and make it loop nicely. This gives us the chance to move this injector around this 120 degrees or so, just in case we ever need to clock it around. We've got that little bit of extra length that can move with that injector. I went through the wiring diagram and allocated each of those colored wires that are assigned for each injector and just made sure that they're gonna be perfect and the right length. So now what I can do is I can run a switched 12 volt, which is our injector power switch, because these are all ground switching from the ECU. So the other side must be the injector power. I haven't run it with this one, but I'm going to cut it short. I'm going to cut it down here. I'm actually going to splice all of those wires together and then run the powers up to here. But what I'm actually going to do to make this job a little bit easier on the bench, I'm actually going to tape and run the injector power with each one of these and run it back down so that it'll make it easy just to cut them all at the right length, and there'll be less work on the table. So I've got the majority of my loom cut in the right lengths and separated into the right sections. I've got a few more to do just sort of down near the starter motor, which is my battery positive for all my fuse box and my relays. I'm not going to do the coils at this stage. I'm just going to get some of this wiring sheathed and braided up the top, which will make it look a little bit less busy so that we can understand what we're going to try and do with this coil wiring. So that's probably all I'm going to do on camera today. Next episode, I'm going to take all of this back out of the car because we know what lengths it all needs to be, and I'm going to do it all up on the desk because it's just going to be a bit easier and nicer to do. So that'll be the next episode. So got my nutrients and vitamins for the day. Thought I may as well show you the we're still open. We're still getting things done here. Oh yeah. Oh yeah. Okay. I'm supposed to be isolated, but we are definitely still open, and we're making as many ECUs as we can, as quick as we can during these isolation periods. We've got deliveries and everything's still functioning as normal here, so we're trying to just get it done as good as we can. So where we finished on the last episode, we had the harness in the car, and I was starting to branch it out off into different sections and starting cutting the wires down to length. So I've got my injector wires all cut down to length, oil pressure cut down to length, the coolant temperature, which has been relocated on this particular engine. That's cut down to length. These will be the gearbox temps and the speed sensor, and this will be our power, crank sensor, starter. There is the knock sensor for that bank here as well, and the ground. So we're going to try and find a good ground for this to go to. Once you break it down, it actually does all make a lot of sense. You can see distinctly where these are all starting to go and how they all work on the engine. We've got our 2 banks and then our 2 temp or pressure and temp sensor. So now all I'm going to do is add in some power wires, which I did on this side in the car. I'm going to do it on this side out of the car. I think doing it out of the car is going to be a little bit easier. Wrangling this in and out of the car as I did it was a little bit difficult, so I'm going to do it out of the car on this side just because it saves a bit of mess. And then we're going to go through and do a bit of braid cover or the sheathing. We're going to do some of that out of the car on some of the stuff that I know is at the right length. The knock sensor, I don't know where it's actually going to go yet because I've still got them sitting here on the bench, so I don't quite know where they're going to go. I know how long the cam sensor is going to be because I measured that, so I can cover that one and put a plug on it. We can also put the plugs on the injectors today as well. Just gone and crimped my injector power, which is splitting off into 8 separate power wires. I've used these ratcheting crimpers, which I found on eBay on the internet. These can do all different sorts of dies and crimps. RS Components is where I get all these crimps from. Super handy and turn up almost the same day if you order them in the morning. Because I'm in Sydney, they've got a hub in Sydney, and it literally turns up that afternoon. So it doesn't matter how ill prepared I am, they're always there to at least get what parts I need. Sometimes they're a little bit more expensive, but it turns up really, really quickly. I know that from where we measured and made the grommet in the firewall or in the tunnel, I've marked that off with a bit of tape, so I know that that's where that's going to sit. I marked it with a different type of tape, so at least it stands out from everything else that's here. Often I use like a red or a green or a stripy tape, just to signify that it is actually different and it's there for a reason. So we know where that one's going to sit. These are all the interior wires that we need to also make sure that we loop them back in or straight on, because they're going to go to other places in the car. So what we're going to start doing now is using some braid, at least to start from back here, use my ignition wires, and at least I know that from here to here I need a thick piece of braid that is going to cover at least this part of the loop. You just saw me crimp 8 wires together into the other power supply wire from the relay. That is just how I like to do the wiring. I've got access to plenty of spools of wire because I do often end up doing a lot of injector looms for people. But if you weren't able to get that much wire, you don't have that much on hand, there's a lot of other different ways you could do it. You could, for example, bring all those wires up and then do a branch off. So you could simply branch off the existing fat current wire and run that fat current wire all the way to the very last injector of the ones that you were doing. So let's just say for the fourth one you were doing, you can split a bit of wire there, split a bit of wire there. Simply twist those together. This is how I used to do my looms when I first started off on my very own car. This is how I learned how to do all of this. I would then pop that up there, throw a little bit of solder on there. Controversial, I know, a lot of people don't believe that solder belongs in an engine bay. I don't mind either way personally. I have never personally had a solder join fail on me, but that's all absolutely personal. What I do actually find easier, and this has got nothing to do with solder versus crimping, I just find crimping a lot easier and a lot faster. We throw the crimp simply in there. Grab our crimpers, give that a quick squeeze on the bigger setting, then the middle setting, just give it a quick pinch, and now that's going to go off to one injector, and then we simply measure and repeat the process again. And it's often nice to use a smaller gauge for your injector power. It just makes it a bit easier when you're trying to move this loom through the car. If you only want to use the bigger wire, you can do that, don't get me wrong, you absolutely can do that if that's all you've got. It just makes the loom really bulky and chunky. So again, we can just throw a real small crimp across there, and basically we run this and pair this up with our injector trigger wires, which are coming from the ECU. And we branch that one off like that, and then we branch this one off like this, and we would just cut them down to length, and then they would go to where you would need to go. Obviously you would cover these with heat shrink as well. Right. Now that we've got our injector power and coil powers spliced out, I've just taken a very good educated guess about how long my coil powers will need to be. These are way more than they will ever need to be in the car, which is great because I'm not going to be caught short getting that loom measured up. So that part's all good. What I'm just going to do really quickly now is get some larger expandable braid, and I'm just going to simply measure this out to where our approximate break is going to be in the loom. We measured this up in the car, and I roughly made a mark on the wiring to say that this is where we're going to start splitting to go up to bank 1, bank 2, and down to the crank sensor and the starter motor and the positive power. So we'll just measure that from here to here within reason, just so we can get these wires bent back around or going where they need to go. Getting this first bit of braid over can actually be very, very painful. We've got to fit this entire loom just to get this down, just down to this section. So it is a little bit painful. So if you can run the next piece with it, so you're not doing the same thing twice, it can save a little bit of time. I don't know if I'm going to do that or if I'm prepared enough to do that yet. So we might just have to do this one for now, and then we'll go from there. It's always an interesting and fun challenge. What you will notice is that I measured probably a really nice, beautiful length for exactly what I needed, but this stuff can be very, very tricky because as it actually needs to expand to get over this entire loom, it actually gets shorter. So often it is a bit of experience that will help you get this shaped and right for what you actually need. This is not a very critical part of the loom because it will get covered by a lot of different heat shrinks and tapes. just to protect it, but I've actually come up probably just a little bit short with this braid. It is often a good practice to measure it a little bit longer than it needs to, thread it all the way on, and then it might be a little bit short or it might be a little bit long. Hopefully you'd want it a little bit long so you could see where you would need or how much you would actually need to cut off that. And you can take that back off, modify it, put it back on again. It is time consuming, but you do get a nicer result that way. In the Haltech premium loom, we do give you a lot of switch 12 volts and signal grounds extra, and they're all bundled in a little group together. They're so you've got enough to run down into the engine part of the loom and inside and supply switch 12 volts to all the right components that actually need it. You may end up, just like I have, with a few left over. Contrary to popular belief in the drift community, you do not twist the grounds and the powers together and for whatever reason terminate them and then put them in the loom. It's not going to end well. I'm talking about you, Anthony. So I've just protected and insulated the remaining ground and 12 volt wires. I'm going to tuck them back into part of the main loom just to protect them. They are there in case we need to do anything with them later on, but chances are we're just going to insulate them and protect them within the loom itself. You can definitely cut them off closer to the source if you like. I, for whatever reason, just like to keep them protected within the loom and not create too many cuts up here just in case anything shorts up here. You can also then go and protect, it just keeps making the loom a bit uglier and bulkier. So by all means, cut them off close to the source at the actual joints, or you can insulate them like this. We've got our loom broken down, covered, somewhat insulated back to the interior. The grommet is going to be in this rough area. I've actually put a red tape on there like I said I would. So that's in place now. So we're going to ignore the ignition coils for a second, but we're going to throw some braid over the coolant temp and the brake hats that we've already sort of somewhat prepared. So let's do that now. We've braided up our loom for the bank 1. Just tried to do it as neat as possible. I've measured out how far the injectors are away from each other on the actual manifold and just roughly made a guide, and then roughly made our lengths equal exactly that there, and the spacing down here about the same, so that they should reach and neatly plug in. So what we're going to do now is just crimp on our injector plugs for at least this bank today, and then that'll probably be the end of the episode today. I will go and do the other side, which is going to be exactly the same thing as we've done on this side, and then we'll come back the next episode and then we'll start fitting some wires back in the car, this entire loom back in the car, to do some measuring up for the other components that we haven't done yet. So much like in Scott's How to Crimp Like a Pro video, just going to bare back a little bit of wire. When you twist all these wires together, it stops any stray wires coming out the side and piercing through the side of this rubber seal, which inevitably stabs you right in the end of the finger, which is the worst kind of pain you can ever have. So
just going to quickly slide the seals just to the end of the wire cover there, just like that. We want to make sure that we've got the pin, we've got the wire situated in that part of the pin, and we've got the part which is going to hug and cradle the actual seal there. So that's about perfectly placed. So we're just going to quickly hold that in place. This can be quite fiddly. I like to try and hold the pin with the end of my finger and my nail like that, if I can, and then give it a quick crimp. So I'm going to use the middle, which is D to start, and then E. That click was not the pin, that was actually my hand. That does that on the first time every single day. And then I'm going to use the rounder seal, which is going to be A. Can be tricky to get the first time. Let's give that a quick pinch and see that pulls down on the seal. I've actually probably gone a little bit too far because I've started pinching one of the grips on the seal. Not to worry for this particular part, because this is not the part that's actually making the electrical contact. This part up here is. Give that a good pull and we can see that that's not going to go anywhere. Often people like to place the pin in the actual crimp first, in the crimper tool, just so it's situated in the right place, and then feed the wire in, and then give it a quick pinch. That click was actually the pin, not my hand this time. And that's crimped that down nicely. And then we're just going to do the rubber. Now we've got our two pins. It doesn't matter, particularly on an injector, which wire is going to go on which side. It is a good, nice practice to get into to make sure they're all at least consistent. So whatever you do your first one, make sure you continue that same format down your loom. It just makes fault finding a little bit easier later on. When you've got this side of the plug, you can always know that this side of the plug will always be the positive and this side will always be the negative coming from the ECU. So we are going to slide the pin in place. This is a little locking tab which is going to click into the little receptacle. Okay, that one's gone all the way in. It didn't click like I assumed it would. That one had the faintest ever click. You probably won't hear it, but I did hear that go in, so I know that they're all locked in. And slide my little bit of heat shrink just to protect the end of the braid and to complete a nice, neat look. Now that that's all done, I'm going to go do another 7 of these. Well, that was a pretty good day. All the meticulous measuring and neatness and attention to detail has really come out because we're actually getting some pretty cool results coming out the other end now, which is great. So that's probably something you can take away from this episode is the more you measure, the more neat freak you are about everything, the neater and more amazing it looks on the other end. Have a good night, everyone. Hey guys, we're back again. Last time I left you, I was crimping on the injector plugs. So I actually stayed up all by myself in isolation and crimped those. And yeah, it wasn't interrupted, so that's always a bonus. Yeah, spent the morning with my mate. Coffee 1, coffee 2, Red Bull, and my other friends over there, you and Tube. And my other friend here, fruit salad.
It's all pretty quiet. It's actually pretty lonely. Hey guys, so we've got the car up in the air now. I just wanted to quickly show you through what we're going to try and attempt to do today. I've got all the battery positives. This is all of the supplies that are going to our relays in our fuse box. The starter motor is just here, and there is a giant battery cable around here somewhere from the old motor that used to be in it, which is just here. So I've got to rethread that somehow or find out where it's actually coming from the back of the car. So I'll figure that out. So we need to maybe shorten this. I'm not really sure yet how I'm going to do that. But this will go onto the positive post of the starter motor, as will this. There will probably be another little joiner which will go up to the alternator as well. So there'll be three maybe lugs that are going to go onto that starter. It may be too much for that actual starter post, so we may need a relocation somewhere out of the way, maybe up here where we can put all of those positives, just so that there's not 50 things hanging off the starter motor and it gets a bit cluttered and bulky and just maybe at risk of a short. So we'll sort that out soon. I've got my starter here as well, so that's going to be on the starter motor, which is our trigger to make the solenoid and the throw out for the starter motor work. Got a crank sensor here as well. That's behind the starter motor on the LS engine, so might have to take the starter motor off and get our hands dirty, which always sucks, but we'll see how we go with that. We may do that later and not even bother. I've measured up the length good enough, so we don't have to plug it in today. We may do that when there's more mechanical things happening later. We've got our knock sensor wires here as well. So that's all in the same sort of area. I'm going to try and route it all out of the way the best of this dump pipe from this exhaust manifold. We might need to protect this with a bit of conduit or sleeving, just to protect the wires from the heat, because all sorts of crazy heat will be coming off this exhaust pipe. So always got to try and route it as far away as possible, so we'll do our best there. On this side of the tunnel, I've got our speed sensor wires. I'm not really sure where that's going to go at this point in time, so what I'm going to do is probably braid this at its full length. I don't know if we're going to run a speed sensor here at the back of the gearbox on the beginning of the tail shaft, or the way that we actually need to run it all the way down to the back of the car. Either way, I'll probably need to make a little extension if it needs to go all the way to the back, but if it's at full length wire, we can get it to here, and if we've got a little bit left over, we can easily coil it up. It's just going to be easier for now. I may not even terminate it because I just don't know where it's going to go, because there is no tail shaft in this car yet, but later on we'll show you what we actually end up doing with this. I haven't seen the trans brake yet, but I haven't looked for it yet, so I might call the owner and ask him if it is in the car somewhere. I feel like most of the time it's actually ending up on this side. What I've done is I've made sure the loom that comes out to the middle at the top, made sure that this is long enough so that it can either drip down this side, or I can go over the other side and make it come out here. Either way, we'll probably ground it to the block or the gearbox. So that's fine. So that's our positive from our solid state relay. And there is a gearbox temperature. I am assuming the temperature will probably go here and try and face away from this exhaust pipe, but it may also get tapped further around in this pan, anywhere in this pan. So I'm just leaving it long enough for now that it can go pretty much anywhere, all around to the back, can go pretty much everywhere. And again, we can tuck it all the way back up on the top of the bell housing, so it's not really a problem.
So last night when I stayed up, I got those injector plugs done, and it actually looks pretty neat. I'm pretty happy with how it's actually turned out lengthwise. It all looks beautiful and nice and neat. I'm pretty happy with that. We've got the ability to move this whole loom backwards and forwards quite a long way to suit whatever needs to happen up this end, which is always the tricky part about building this out of the car. I've done this side, the injector loom as well, which you can probably see in this camera. I've got my cam sensor, which is just down the front on the LS2, so I've got to put a plug on that one. I've done very quickly a boost control solenoid down here as well. I've wrapped this in a bit of conduit and some electrical tape just to safeguard it against all the hot area that's around here with the wastegate. There's a dump pipe here as well, so I'm just trying to protect that wire the best we can. The knock sensor for this bank is also on this side, so I've got to put a plug on this one as well. Before we were talking about running the actual flex sensor and the fuel pressure from somewhere inside the car and trying to avoid all of this. There wasn't a lot of room under there with the heater box and the aircon system that is still in this car. So that was actually quite difficult. So I've actually then rerouted this back inside the grommet again. And what I'm actually going to do with this is I'm going to run it across the top here and then back down with these hoses, so we can do the flex sensor through a little hole down there, and we'll do the fuel pressure sensor here. So there's not much I could do about that one. I don't really like where the wire's going, but there isn't really an option in this application at the moment. So on this side, we've got the electronic throttle here, which is where I've got these 6 wires go for the 6 pins inside that drive-by wire. So we'll put a plug on that one very soon as well, but you can see how that one will sort of measure up and plug in there. I've got an air temperature made for anywhere that's in this sort of area of the intake manifold. I'm not really sure where it's going to go, but I have a feeling it's going to come out of here and then snake down through that giant hole down there. So that's the idea. So we can run that pretty much anywhere. I've got a set of fans which are going to come out, up and over and around and plug into this plug that's here. Just important to note, I've matched the gauge of the fan wiring. There is a ground here as well, so that ground is going to ground to the head of the engine. It's just a good solid ground that we're going to use. And this wire down here, this is our alternator control. We're not going to use a globe in this case to excite the alternators to start it charging. We're actually going to try and control it through the ECU, like we mentioned in one of the first 2 episodes. So the plug for that is down there, so we'll bang a plug on that as well. So I've quickly just thrown a plug and the cute little boot, which actually just makes that pressure sensor look really nice. I'm going to work over this side for a little while now, and then I'm going to tackle the drive-by-wire plug, which is going to be our E-throttle. So I'm going to do that one up just here. I'm going to quickly throw a plug on our air temp sensor, our alternator plug, and I've quickly just done the thermofan plug. I do want to use a bigger gauge plug, but due to current lockdown, I can't just go out and grab one. So I'm going to maybe replace that one in the future. I've just used the other side of what was on the fan already and just reuse the plug, but I do want to change that in the future to a bigger gauge power plug, because it might need to carry a bit more current. On those hot summer days, those fans will be working really hard in Australia. So I'm going to quickly do the rest of those plugs now. Before I went ahead and crimped on these air temp plugs and the coil plugs and the flex fuel sensor plug, I thought I might just clear up a couple of things really quickly. These connectors that are commonly supplied with all the Haltech sensors that you buy, these are all pull
the big tab on the top of this pin signifies that you actually push the wire all the way through first, crimp the wire on the end, and then pull it back down, and that big tab actually slots into that slot right on there on that connector. That's called a pull to seat connector. This one here is actually a push to seat connector. So you can see it's a very, very different style of pin, where it's actually got some places here on the pin where it actually locks. See these little tabs here? That's what those little tabs actually lock into on that pin. So you can often tell it's actually got a big cap that actually locks all those tabs in place and keeps that pin retained in its little space there. Same with the flex fuel, uses the same type of pin. This pressure sensor as well also has these little tabs on it that locks into the little hole on that pin, and the little cage holds all of those tabs in place so that the pin can't back out. These pressure sensor plugs, which come with all of the Haltech sensors, use a similar, very, very similar style, but these are also pull to seat. So you push the wire all the way through, crimp it, and then pull it back through. If you follow the instruction guide that comes with every single plug and sensor from the Haltech manual that is supplied with the plug and the sensor, you won't go wrong. So I'm quickly just going to wire this air temp sensor here. This is a pull to seat. So we're going to quickly thread the wires through this connector. I've pre-heat shrunk this one, so when we're done we can push the heat shrink up and then melt it for a nice neat installation. Keep going, push these wires through. It will be a little bit tricky the very first time because the rubber is nice and sealed. So we'll push that through. Don't be afraid to push this all the way back if you need the room for your specific stripper. Strip back a tiny little bit of insulation so we've got some wire available. Take your pull to seat pin. There's no rubber grommets that go on the back of this one, or seals, because the connector has already got one on the back of it. So it's one less thing to worry about because you're already trying to think a couple of steps ahead by pulling these wires through in the first place. So we just make sure that those crimps are done up nice and tight on the actual copper itself. Just twist this one. Always try and keep your pin that you've just done out of the way. Can't even tell you how many times I've crimped this pin, got it absolutely beautiful, gone to crimp this one and somehow got this one tangled up in my crimper and absolutely mangled it. So try and keep it out of the way. Otherwise you're just making more work for yourself. Nice and tight. That's all done now. So we can pull that back through, and there's little fins on these pins. We've just got to flip them around so they go into those two little slots there. So we'll do the ground one first and click. You can hear a really, really faint click when you do it. And there'll be a click. So they are both seated. I'll push that rubber seal back up, which has got a little bit of a twist on it. Just gently caress that back in. Pull our heat shrink back up to its position. Just going to give it a quick hit with the torch. We've got a beautifully crimped, ready to go air temp sensor. Crimped on my pins and seals onto my wires for my throttle body here. now I'm up to the part where I need to know what the pinout is and the wire assignment for this particular plug. For me, that was as simple as jumping on the internet, going to Google and typing in this engine's throttle body pinout, and it came up pretty easily. So if you do have something pretty weird and obscure and you really get stuck, always just give us a call or send us an email here at Haltech, and one of our representatives will be able to help do some research with you to try and find out what your particular throttle body pinout needs to be. We may even have a document that's already done that we could just supply you so that you could get your Haltech wired up.
What I want to talk about right now is these two wires. You'll see one is a normal insulated PVC wire that comes with majority of the loom, and then you've got these AVIs, which is AVI 1 and 6 in the Elite, Premium and Basic loom, and SPIs 1, 2, 3, 4 or DPIs 1, 2, 3, 4. One of the most common questions we actually get in regards to these particular wires is, why does my signal always appear to be grounded? And the most common reason for that is because there is actually two layers of wire inside these shielded wires. And most commonly, what people do is they just get their stripper and go honk like that, reef it apart, and then they just pull all the insulation back and go, sweet, I've got one wire there, crimp the grounds, which are the shield wires, and the signal wires together. They crimp their pin on that, and then wonder why their sensor never works properly. And that's because we've actually got the shield, which is a insulated layer that is protecting the signal wire inside. This is actually connected to ground back at the ECU connector. So we don't want to short our signal to ground. What we actually want to do is trim back very carefully the shield wires, and then we want to make a clean cut at the signal wire up here, and then crimp our wire to the signal wire only. So here we've got our normal wire, which is just a single layer of PVC covering the copper. But this is our multi-strand, which I was talking about, a shielded wire, which has got a layer of shield around it. If we undo the shield off that layer of PVC inside, you'll see it's just like a wire on the inside, but we need to carefully pull all that shield back out of the way. Just give that a quick cut with your side cutters and make a nice, neat cut so that it's all protected and not going to interfere with the actual signal. But we need to have the signal wire available clear and free of this so that it gets the actual signal from the sensor it's being attached to.
Last few things we've got to do for today. I've got the factory oil pressure sensor, which is hiding down the back of the manifold here. So I'm going to throw a plug on that one really quickly. I'm going to braid these wires here with some of the sheathing. I'm going to separate these down at this join that I made here. So we'll make a big fat common one to here, and then we'll split all of these except for the power ones, and then we'll run that back down under, and we might need to just throw a little bit of protection over these wires as it runs past the manifold.
So a quick recap of what we've managed to crimp today. We've done the actual drive-by-wire assembly itself, so the actual butterfly will move now. I've done a crank sensor really quickly here today. The knock sensor, I've put a little ring on the starter motor and just put a little band on it just to signify that it is going to go with the battery positive stud, just to show that it is not a ground wire. It is going to be a positive power to the starter wire. Got my ground over here. Got my air temp sensor, which I've terminated. My alternator wire, which is going to control the alternator voltage. Got our plug, which is temporary for our fans until we can source a better version. I've also done fuel pressure, which is going to live over here in the sensor, which is coming in the reg. Our injector plugs are all done. I've got the cam sensor, that's done, and that's ready to go under here as well. I've got the other knock sensor, which is buried and stuck, and there it is. Our other knock sensor, so that's for the other bank. That one's done as well. I've got a boost control solenoid wired up. So I've got a little bit of protective covering, as it is right next to the turbo itself. So we've protected that the best we can. Haven't measured out my coils yet, but I'm about to go under the car to do the flex, which is running down here. So that's running through a little sneaky little hole down there, which is actually in the car already. So we've utilized that factory hole. And you can see the flex sensor just under there. So that's where this wire is gonna go, down here somewhere. So after giving the customer a really quick call, we talked about where the wideband box will go in the engine bay. It's not a showpiece, it's not the centerpiece of this engine, so we're going to try and sneak it away somewhere quietly, but still functional. The beauty of the waterproof box means we can put it out in the engine bay and not clutter up the inside with more devices. We're going to pull apart the CAN cable and then sneak it maybe through the wiring harness when we need to do that. But we could also use maybe this clutch hole, or we could use one of the other holes that are already existing in the car. There is a couple here that we might be able to utilize. So we'll figure that out when it comes to actually fitting up the harness, where we want this cable to actually go. If we are going to run this through the firewall grommet, it is very, very easy to pull this connector apart. This comes with the wideband and is the communications cable that goes from the wideband down to the ECU CAN plug. It's very, very simple to pull this plug apart, so you can get it nice and compact and fit it through the grommet where the loom is. We're just going to pull out the locking tab, which comes in the connector. Then we use one of our removal tools, our pin removal tools, which comes in our crimping set from Haltech. And there is 4 little tabs that we're just going to flick really, really quickly and just pull down on each of those wires, and then it simply comes apart just like that. So we can throw some tape around that so these pins don't jag on any other bit of wire or braid. And then we'll simply push this in through the grommet, and then we'll have this connector simply put back together. Once it's back in the engine bay, we'll use the same color code that's on the back of this connector to know where each of those pins needs to go on this connector. So last quick thing for today is just to plug in this knock sensor, which I terminated earlier on. And that will be us for the day, I reckon. Click, beautiful. I've just got a couple of connectors to do, which will be pretty quick and pretty easy. This one's the trans brake, so we're just going to leave this one because I don't know where it's actually going to go yet. The temp, we'll just get a simple oil temperature sensor plug, which is the Haltech one, so we'll just put that one on there. And then we've got our yellow wires, which are up in the engine bay. I've still got to do those. Those are our ignition coils. So while the car's up in the air, I might measure where they're gonna, how far away they are from each other and how long we might need those wires to be, because it's gonna be a tricky one to try and crimp it where it is. So I may actually end up unplugging everything, pulling the loom back inside the car a little bit, and then doing some of that inside the car. While we're inside the car tomorrow, we'll probably do the accelerator pedal as well. Find the ignition switch, plug in our Haltech dash, and then we'll see how we are from there. Oh, well, that was no good. Welcome back. Another day. We're going to do some more wiring today, funnily enough. I don't even know what day it is. I've lost day of how many days we've been doing this for now, but we're back on it. Ready for another
wiring adventure. So we're inside. Excuse my bed. Oh, I've been looking for this torch. Today, I'm going to quickly measure up the drive-by-wire pedal. Obviously, it's going to live over there in Australia. In America, it's going to live over there. We're just going to measure out how long this needs to be. And then I'm going to print off a diagram that we've got on our server here at Haltech for this exact pedal. It's around here somewhere. For this connector. So I'm going to get a diagram. We're going to split the ground and the 5 volts twice, because there is 6 pins in here for 2 pedal circuits. So as you press this, one circuit goes up and one circuit goes down. And the ECU looks at both of those together as a safety measure for the drive-by-wire. So we're going to quickly measure up that. We're going to split these up because I've got 2 buttons over there which I need to wire up as well. And the ignition switch for the ECU, which powers it all on, that's going to live over there as well. I don't really want to get under there that badly. So that should give us just a little bit of leeway and margin of error, because this might not be exactly where it needs to be, but we could loop it up and go the long way around if it's a little bit too long. Again, never come up short. So we've put the braid sleeving over the top of this wire that we have run through for the drive-by wire. We've got it roughly 10 centimeters longer than we need, which is perfect. We're just going to route that the long way and just make it go where it needs to go. I've got the pedal in this mess here somewhere, and the original plug that came from the car. The factory wiring colors and the pedal diagram was a little bit hard to find on the web, but I managed to find something in a factory manual. So I've actually contacted Dave from Haltech in sales and tech support, and he's made an awesome diagram for this pedal, which is great. So if you ever need pedal diagrams, by all means contact Haltech and we'll see what we can find in our resources to try and give you a hand with all that sort of stuff. Definitely not a problem at all. We're not going to use the factory connector with the wires. By all means, if you can't get a replacement, this is going to be the way to go. So you can either put a new plug here, which will join the wires that are coming in from your new installation onto the existing wires, or you can get a brand new connector. Absolutely go that way. It's the best way to do it for sure. So brand new pins, brand new seals, brand new connections, reliable, and you know that it's done right. Just going to cover these joins up real quick with some heat shrink. Delightful. This is not any of the crazy dual wall heat shrink. This is just normal heat shrink because it's all inside and it's nice and compact. And it just works for what we're trying to do here. Pull off my hold the braid back tape, because I don't actually need this in place there anymore. Starting to fray a little bit at the end there, which means I obviously forgot to melt that and protect it before, and then burn your fingers. Oh jeez. A great incentive for doing it the first time right. And then that's probably where my heat shrink will end up going, and then it'll just give us a nice bit of flexible bit of wire, so we can put that plug on there, and that plug will probably sit about there. So it should be pretty good. We'll just keep that in place, that'll keep that in place, and let's have a look at our diagram and figure out where these 6 wires need to go. There's our diagram real quick, just there. Strip the ends off, we'll crimp some pins on, and then we'll get this connector out, which you can see in here. Should be fairly straightforward. We'll just figure out which way is the back, which one's the front. But that's pretty much us, so we just got to follow the diagram. I'll do the first one, and then we'll get it all plugged in. I've just got my last one to do here real quick. Sure it's a nice good connection. Now I'll just get in there and just make sure that they're all pretty good. Bent maybe a few of them just doing the crimps, but that's easily adjusted and fixed. And looking at our diagram, you can see that the plug is actually facing back to front, so we've got to make sure that we get the orientation right. Now, on the factory connectors, I'm pretty sure these also all say A, B, C, D, E, F, and on this connector, they say 1, 2, 3, 4, 5, 6. So it's about lining it all up and just making sure that we're actually lining up the right things with these pins, just like the picture says. So, if we start at the top, we need a 5-volt wire, which in the Haltech colouring is plain orange. There is a very hard to see in the light, but there is a yellow one here as well, so I just need to make sure that it is plain orange. So that one's plain orange, and A, so that will go there. I'm not sure of the orientation of this plug, I haven't seen it in a while. So that one just went in pretty nicely, and I heard it very faintly click. The next one is going to be a 5-volt, so I know that I joined those 2 wires together, so I know that it's going to be that one. Yeah, click, that was pretty good. I liked that one too. The next one will be one of our signal wires, so that'll be our yellow or our green AVI. That one doesn't feel very nice, so we'll try that again. That could be because I bent that pin a little bit in the crimping process. Straighten him back out. And that's got it going in now. Yeah, that one appears to be in as well, so that's good. Next one is going to be a ground, then the signal is going to be the last one going in. Bit of a weird orientation for these wires, but we don't make it up. That's what comes from the factory. That one clicked, so that's nice. Speaking of the factory pedals, while I'm doing this, it is probably also good to know that just because I'm using a GM engine and a GM pedal, it doesn't mean that they have to be specific to the same brand or family. We could be using a WRX pedal from a Subaru, we could be using a Nissan drive-by-wire from a 350Z or a Maxima, we could be using a Mitsubishi pedal. It doesn't really matter with the Haltech stuff because the calibration of the ECU and the settings in the ECU pretty much takes care of all of that part. So it's really whatever you can get your hands on for the right price, and what fits in your application up here, which is the tricky part. That's what really matters, what size and what fits and what's available in your particular region. So just got to get this last one lined up.
click, that's it. So that's actually pretty cool, man. Nice. So now hopefully if we pull this apart, hopefully it plugs straight on to our pedal up here, and it might be facing that way. That's it. All right, well, that's us wide. I'll just heat shrink this down a little bit, and then that part's done, and we'll move up to the buttons and ignition switch. So I've got myself in a little bit of an awkward position here. I completely forgot. I was on such a roll and getting it all done that I forgot about the starter lockout. Very, very important for engineering purposes, and also when you try and start your car in gear by accident, that the car doesn't roll down the road. I've seen it before. It's not great. So what we've got here is a reverse light and a power. So these were in the car before, so I've sort of somewhat salvaged and rescued these wires. I've just put two different identifiers on them, so if the owner or whoever's going to work on the car pulls it apart, they know where they can at least go back. So I can mark this top one red, and then the bottom one will just be black, so that should be fine. Just saving myself a phone call on that one for when the owner pulls it apart and goes, what do I do now? So we haven't quite decided on which start button we're going to use yet, but he's going to do some browsing to figure out what he wants to use, so we can figure that part out. What we're actually going to do, we're going to take a 12-volt signal, which essentially comes from the ignition switch. That's going to loop onto one side of the button. The other side of the button, when we engage that button, is going to get that switch 12 volt, and it's going to pump that 12 volts down that other side of that button, which is going to go down the long way into this micro switch, so that when this is in park, not reverse, neutral, and then not in any of the gears underneath that, it'll actually have continuity that goes back through and then goes into our ECU trigger wire, which is this yellow wire here. The beauty of the start switch with the ECU is that we can have ground on the other side and turn the pull up in the ECU so that there is a giant point of difference. So it rests at 5 volts, and then when we want it to activate, we pull that signal down to ground. That way it doesn't false trip or anything like that. So it can only work when the ECU is on. So that's what I might actually do. I might actually run ground to one side of the button and then the ECU signal on the other via the micro switch down here. I've got a wire run from the back of the car, which is here. This is going into the reverse lights at the back of the car. The other side of the micro switch here will have 12 volts on it, because that's what the reverse lights need to trigger. Seeing as there is no reverse mechanism on this gearbox anymore, there might be, but it's just easier just to use this since we've got it up here. This only works in reverse, so the switch arms itself, and then it will put 12 volts into the lights at the back. Again, this is a requirement for many states, territories, in many countries, or for engineering purposes. It's also a good safety measure.
I am not very camera savvy at all. I thought it was recording when I did all of these, but it wasn't. So I went ahead and did all these and thought I was filming myself, but failed miserably. But as you can see, I've done a lot of these coil connectors now, which is great. These were fairly simple. These connectors are push to seat. So the grey ones that we took a quick shot of earlier were the pull to seat ones, where you got to push the wire through, crimp it, and then pull it back through. These ones are very like genuine. You push to seat these ones. So I've got 2 more to do, which I looked up at the camera and saw that it wasn't flashing, but at least we'll be able to see these last ones getting crimped, and then I'll assemble that connector for you. Quickly straighten that pin out. Give that a crimp with the smallest die that we've got available on the crimper. Just get it nice, solid tight crimp right down on that bit of copper. And then we're going to use the big roundy one just to crimp that insulation and hold that in place nicely. Just do the ground real quick as well. And then pinch that with the tightest one we've got. Give it everything you've got. That's on there nice and tight, like a doiker. And then we've got that one smashed on as well. So happy with that. Now I've got my diagram, which actually came with my coil set from EFI Hardware, that tell me how to do it. Where like the actual pin out of the connector itself. So I'm going to quickly do my switched 12 volt over there on the far right hand side. Click. Just make sure, so if you're ever not sure which side or which way the pin's meant to go as orientation for the actual connector that you're looking at, there's always a little locking tab. We should hopefully be able to see that come in. Oh, the only one I've stuffed up so far, classic. That will go in and just push forward again. Sometimes I get a little bit caught up depending on the connector. Click. It was a fine little click as that tab went down into that little glory hole. Line this one up so the connector hole is facing up. Slide that in. Click. That one's all seated now. Using a late model LS coil makes simplified wiring so much better for this exact type of wire up. If we were wiring an external module in, we'd have to wire a signal from the ECU itself, loop that into the ignition module. That module then goes out to the coil, and then we've just simplified the amount of crimps, the amount of wire, the amount of issues that may be caused from just the complicated wiring. This just makes it so much easier to wire a car. Basically what I've done with the grounds in these is I've brought all those individual grounds to here, and then I've put on a bigger cable through a lug, and I've actually crimped that all together. So I've got 4 big fat grounds which are joined to 2 coil outputs, or 2 grounds for each of those coils. And then we're actually going to ground those to the head, just like our little diagram here has down here. So that's going to be very, very easy to ground that. We're just going to find a nice big bolt, probably one of the coil bracket bolts on the back of the head. Just a nice, easy place to put it. So I'll cut that down to length. I've left myself, probably about that much more than I actually need, but that way I'm definitely going to get to where I need to be with the amount of wire I've got.
The owner has been watching a lot of Street Outlaws by the looks of it, because his street car has got these bump and creep buttons. These can get in the way, particularly when you're driving a car around on the weekend like this guy will want to. These do actually get a little bit annoying. They're always going to be in the way. It'll always get tangled. It'll all just end up in this mess, and then you'll have to essentially pull off your steering wheel, get it all sorted out again. So what we're going to try and do in this scenario, I just spoke to him on the phone, and we agreed that it might be just a good idea if I bring these under the steering wheel here, combine these into a 4-pin plug, because there's 2 wires in each of these curly cords. That'll just sit under here, under the steering wheel, and then I'll have the trans brake and creep button on a plug that we can just disconnect very, very easily, and then just store up around here somewhere where it's not part of the turning mechanism of the steering wheel. It'll just make it a little bit neater and a little bit nicer for driving it on the road. When he goes to the drag strip, he can simply plug it in, or when he's on the 405, he can get on there and get on the trans brake and then try and win some money. Traditionally in a race car setup, however, a lot of people like to have the trans brake in their B&M shifter. There is another plate that you can actually replace this plate, and it has a little button in it. That's just a momentary button, so you can activate your trans brake there instead of up here. The owner wants a trans brake and a creep, or a creep and a trans brake. It doesn't really matter which way, because you can just swap it within the ECU. So if you wire it in such a way and you don't like it, you don't have to physically rewire it. You just assign those pins differently in the ECU. But traditionally, if you're going to have the trans brake, you could have it here in the button, and then you would activate the button only under certain conditions. You can also have it on this side, depending on which country you're in and which side of the car you're sitting on, and which side your thumb would naturally go to. So again, we will just run the wires down inside the trans brake mechanism through here, through the wiring crevice or crack in here, which is made for the wire to go through, and then we run it that way instead of running it through the steering column section here.
And because I'm only human, I've made a mistake. I could edit this video and undo every single bit of work that I've done up that end of the engine, and then slide over a new piece of heat shrink here, because I forgot. I've been harping on about planning, and thinking and planning the whole video, but then I got a little bit excited one day and I just rushed ahead and I forgot to get a bit of heat shrink that would fit up there. So I'm gonna, it's not the end of the world. I'm gonna get some nice fabric tape or fleece tape. I'm gonna cover this joint so it is nice and so it doesn't fray and fall apart, but I'm not angry, I'm just disappointed.
So I've done my coils. I don't love the setup of the wiring. I don't like necessarily where it is, but I don't really have a choice, unfortunately, in this tight confined area down the back. So it is what it is at the moment for this particular wire up and this particular layout of the coils. Because the leads haven't actually been made yet for this engine, we could juggle the coil order backwards and forwards. I took the best rough sort of measurement I could with a ruler to try and get the best layout for the connectors. It was just a little bit tricky, and I don't love it, but it is going to work. It is done correctly, and it is hidden, so it's not the end of the world that you can't see how uneven they are down the back. So if the engine ever comes out because Rodney comes to visit, we might get a chance of neatening up and redoing the lengths on those particular coil plugs, if I ever really think or feel that I want to redo that. To help neaten the engine bay up a little bit, the factory loom for the headlights and the blinkers and parkers and all that, even the wiper motor jet, so that the little jets can squirt water up onto the windscreen. All of that wiring, classic 80s, used to just come straight out of the strut tower, dangle around the battery here somewhere and split itself in and around all over the place. And then it would go to the headlight, under the radiator, and then back up to the other headlight. What the owner has asked is that we could drill a grommet into the strut, or this area of the car, whatever it's actually called, and feed the loom instead through here, and then tuck it under the part of the car here where the fender normally sits. We've tucked it up nice and neatly out of the way. He said, hey, just drill a hole in my car, it'll be fine. And I said, how about no? So he came out and drilled it himself with a hole saw. I've used one of the Haltech grommets that actually comes on the loom. You can actually buy them separately from us in 2 different diameters. You've got a bigger hole for the bigger looms, and there's actually a nice, neat, small one. So we've used the nice, neat, small one down here, and we fed the loom back through. That left us a little bit short for things like the brake warning light and the windscreen wiper motor. So what we've actually done is pulled apart that loom and actually separated that loom back, and then just retaped it all up nice and neat. And this is all factory, so we didn't have to actually extend anything, which is great because I didn't really want to. I've got my little magic carpet which stops my knees getting dirty. Save my dirty knees for my next pay rise that I ask for.
This fabric tape is awesome. It's been making auto electricians look impressive for many, many years now. This stuff's great. It really just makes a job look really professional, really finished, and very neat, no matter what bastardry is happening underneath, which is great. So I tend to start up one end and then work all the way back, and then even when I get to this join, I'm going to stop, and then I'm going to do this one, and then I'm going to work up to this join and then stop, and then I'm going to start and cover both of those ends with a new piece of tape and go all the way back so that there's never an exposed or end of the tape that's ever going to unwrap itself and let itself fray out. I'll show you what I mean by just going around and going up and just slowly spiraling it. You can see how much neater it looks already. This look isn't for everyone. Some people prefer the look of DR25 heat shrink, and they'll unpick all these connectors and run brand new heat shrink over everything. I just like to get the job done with it looking very neat, very clean. So just go under that connected clip there. Because this isn't in the factory position anymore, I don't really need these clips anymore because they've got nowhere to be. And it gets a little bit tricky at the top, obviously, because my giant roll of tape gets in the way. But I'm trying to get up as high as I can. And then wrap that last little bit up there, like I said before. So what I'm going to do now is go up this side. When I get to here, like I said, I'm going to start a new piece of tape over both those, and then work my way all the way back down, basically to the grommet where it's all neat and protected and nice, and it will never fray apart. So I've used some of my best trimming skills to get this interior looking mighty schmick again. Actually, well, the best I can, to be honest, because I'm not very good at this part. All these offcuts, depending on how nice I feel, I might vacuum them up, but most of them are just under the carpet. So the fuse box can go up there somewhere. I've got a solid state relay which will crimp on some little eyelets. That's for our transit brake. ECU connector. And I've used my my best carpet maneuvering cutting skills to get around the little grommet, so we've hidden that in there. Give that a little tuck job, and it looks factory. Now that I've gone ahead and cleaned out the lounge room, I'm gonna maybe sleep up in the race seat tonight, so that might be fun. I'm just gonna wire up my trans brake buttons, so I'll do that probably tonight just before I head off to sleep, and then tomorrow will be another day where we'll tackle some fuel pumps and the ignition switch, and we're going to do the fan at the rear for the transmission. Trying to think of many other things that we need to do, and I think we're getting very, very close, so that's pretty cool. The glaringly obvious one, obviously, is this giant chasm in front of me, which is the dash. So that'll be the last thing that we plug in, I think. So we'll do a quick talk about that tomorrow. So I might just try and catch some Z's. What? Hey guys, I thought I'd get out of the house for a while and move into a luxury hotel for the night. So, luxury,
So I'm just taking it in, and I suppose I better get back into it and get some work done, because this is the final day. So while I've been staying in my luxury hotel, I've been taking in the beautiful views, which are right there. So that's pretty cool. This is like a dash background, which is just like the one that we're going to get from 3D Racing Solutions. So they make all the cool dash holders for all the different brands, but how good does that look? It's pretty cool, isn't it? So better get out and get to work. So today we've got a few things to check off and get done, so that should be pretty cool. I've got some fuel pumps, a fan, I've got the dash to finish up today. We've got our cluster back from 3D Racing Solutions, so that's pretty exciting. So we're going to do a dash install of sorts. It is only the prototype for now, so at least we'll see what the shape and look and feel of the actual dash install is going to be. I've cleaned up the inside because it's getting pretty gross, but the nicer this car is getting, the more disgusting and feral I feel. So let's just wrap this up so I can go home and have a proper shower. I am getting pretty sick and tired of getting under here and changing things, so I may as well just stay here and just get all the stuff done under here that I need to. I've got this battery crimp terminal that I've got to put on with these Tempco mini battery crimping lugs, I guess, or big terminal lugs. This is a great little compact thing, particularly for doing smaller little ones like this sort of crimp under the car, particularly when this is down on the ground and you're lying under the car trying to do these up. These are really handy, so definitely have a look on our website. We've got these coming hopefully very soon. Shipping being a little bit delayed, but I feel like these will be here really soon for sale. So if you need a tiny little pair, we'll have these available soon, so that'll be cool. But basically I've got all these battery positives which are coming from the fuse box, and there is one there for the solid state relay for the trans brake as well, from memory. So all of these are tied in and they're ready to go, so I'm just going to try and quickly throw a quick crimp on this, and then we'll latch it onto the starter motor. Got a beautiful crimp on that terminal. You can give it a really good pull, and it seems to be holding on there really nicely. You can get a whole different variety of crimpers ranging in size, length, price as well. You can get really cheap versions of the same one that I've just got. You can get them very cheap off on online stores, and a big variety depending on what you actually need. But I have found, since I've actually spent the money on a genuine one, the genuine one is actually really good. It does make a big difference down here, and it lasts a bit longer. The cheap ones that I got seem to run out of grunt really quick, and the oil wasn't in the seals, and it's not quite up to the task of doing many lugs over many different cars. If you're looking to just do one car, absolutely grab the cheap one. If you're looking to do a bit more wiring as a career, definitely invest in the more expensive ones. So I'm pretty much done under here, finally. I forgot about this knock sensor real quick, which I'll just sneak through here. Taking it on and off a few times just to get the length right. So, I actually think we're done. The car's got to go away for a while anyway and get finished up. So when we're actually ready to start this car, we'll go over the entire thing one more time, because you never know who touches it while it's away. So, last couple of things. We've got a transmission temp. That's what's going to go in this little bung underneath here. So we can plug that one in. We don't necessarily need to do all this mechanical part. If this is full of fluid, I don't want the fluid going all over me, going down my arm, going in my armpit, going in my shirt, and then I just smell weird. Not interested. So it's there for somebody who wants to put that in now. I'll cable tie all these wires up out of the way. Trans brake wire, which we've talked about a few times, that's here ready to go. The trans brake was in the side of the gearbox the entire time. I just didn't know, so we just need to put a spade terminal on that, so that's already done. And the speed sensor. When we figure out where this is going to go in the drive shaft, that'll be easy. We can either put a small extension on it to get it to a Hall effect sensor down there, or we'll just coil up the extra wiring that we don't need and we'll put a sensor up here. Flex fuel, so that's up under here. The return pipe will come down from the actual fuel reg, sneak through the chassis rail, and then it will actually go straight into this part of the flex fuel sensor. The other side of the flex fuel sensor will then basically go into either this return line here, or if he wants to run a new style like Teflon hose, he can do that on this side, and that will go back to the tank as a return. So there is a fuel filter there from the old installation, but I don't think that's going to get used again. We'll probably swap that out. So more or less, I'm just going to maybe put a spade terminal on this one here. Sorry, while I've got it here, I've also got a transmission pressure. So if he ever wants a line pressure, we can simply have that sensor ready to go, maybe on a remote line, and we can mount that sensor up under here somewhere. So don't know if you can see it. There's the trans brake. So there's we need a ground and the positive. So simply we're just going to take that positive, put a spade on it, and then a earth, and I'll earth that to somewhere metal under here. This is my power probe. I freaking love this thing. It is so helpful when you're doing particularly a full wiring harness for the entire car. If you need to do testing to find out which one's the power, which one's the ground, which one energizes something to actually turn it on, just to see if your circuit is actually correct, this thing is great. I'm going to show you just really quickly what it actually does and how it works. So I'll go plug this straight onto the battery that I've got on my test rig up the back here, and then I'll show you how to actually make it work and use it to your advantage. So I've connected it up to my battery. So I've got 12 volts that comes out the tip when I press up, so that's really, really handy. I've got ground coming out of this tip now when I press down, so that can negatively drive anything. And I've got a little ground strap here which is actually attached and basically goes in and straight back out again as the actual battery negative. So I'm going to put the battery negative on this little earth eyelet which I made a long time ago for the actual fan wiring, and I'm just going to show you really quickly how this works. Basically I'm going to put 12 volts out the end here, and we've got ground on the other side, so hopefully at least one of our fans turns on when I back probe really quickly. You can hear our fan turn on. So we know that the fan's actually spinning the right way because I can feel it pulling air through. So that's just a really quick way just to make sure that you've actually wired it correctly. Another really cool thing when you've got this pointing somewhere off in the VEG and you're under the dash and you can't quite see what you're doing, you can actually turn an audible noise on. So you can, this is also really handy, particularly if I wanted to have this on a wire up the front, and I've actually got to find out which wire it is down here. So I can have that basically sensing ground. So when I do find the ground for that wire, that's the noise it would make up there. So it makes it really easy just to ground a couple of wires up here when you've got the battery disconnected, and then you can find that when you're up at that end of the car. I'm going to do a very quickly show you how I found the reverse lights in this particular car. I went to the plug that went to all of the different lights down the back here. I grounded the actual lights using the little strap. I'm going to do that so that we can at least put 12 volts straight down the plug and into one of the right wires, and hopefully this is the reverse lights. And there we go. We can see them just ever faintly turning on, which means perfect. That's exactly what I need to do. So I've extended that wire all the way up to the front of the car. We're going to use the little micro switch that is on the side of the actual shifter to find the reverse light. So we've got to put power into one side. It's got to go through the micro switch and then back out the other side, which actually ends up back here. So we'll see if that turns on the reverse lights now. So I've quickly rigged up my switch to 12 volt, which is actually going to come in on the other side of this little micro switch here. I'm going to do some really quick testing. This is step one. Step one is putting 12 volts in through the micro switch, and hopefully that has now made the lights turn on at the back. So I will go and review my camera footage of my GoPro at the back to see if that actually worked. Yeah, so it did. So that's perfect. So that's that's working really well. So now this will help me find a good switched 12 volt, which is coming from at least the ignition switch. If you leave this in reverse, when you put this side on the battery, it'll stay on overnight if you just happen to leave it in reverse by accident for whatever reason. So we'll find a good switched 12 volt, maybe from the actual ignition switch or something like that, so that we can actually power up the reverse lights and they can come on when they need to. So we got our cluster back from 3D Racing Solutions. This is a very early prototype that he was able to rush together for us. So he took away our original one and then started drawing up this one and got it printed just in a few days. So that's an awesome effort from Sam. I really appreciate him spending some time getting this one up and running for me. So we've got our IC7 dash here. So let's open it up and see how it all looks. So in one of the earlier videos, we were talking about what things need to go up to a dash. Typically you would have a tacho wire, which would come from either your coil negative in your car, or in this instance, it would come from your tacho output on your actual ECU. We don't need to, because all we're going to do is simply connect up the CAN plug, which is going to bring across our tacho. We can do our vehicle speed, our coolant temperature, battery voltage, and pretty much any other parameter that is coming through the ECU we'll actually be able to just display on our dash very easily. So instead of wiring an extra coolant temp sender, a separate speed sensor for the gearbox speed, a tacho wire, all we're simply just going to do is, and she's wired up, just makes it so easy. We're going to quickly connect up our comms cable as well, so that we can program a dash and make it change all cool colors, and we can put some cool pictures of logos, or I don't know, maybe like a Ford or a big XD, or maybe a Street Outlaw symbol, or whatever really takes your fancy. So very quick installation. That's pretty much installed. I can take out these two screws at the top, which are holding this in place for now. I won't bother because it's only a test fit, but we can make sure that those 3 holes line up for the screws that hold the dash into this fascia. This gigantic dash surround shroud thing, which is actually so heavy. This fits just like that and covers up the existing dash surround, which goes right there. So there's a little bit more drawing to do. It is only a prototype at this stage, so he's got pretty much the tabs in the right place, but we've got to change a few more things. So once that's all done and painted up, this will look mint. So we're getting down to the business end. This is all very, very exciting. As some of you eagle-eyed viewers might have seen in the last video, we've actually got battery power. There isn't technically a battery in here. We've just rigged up some jumper cables onto a battery, only because I just want to test what's going on at the moment. So basically, if I turn this on and then on, basically this is past accessories. Now we're onto the on, or the ignition. So basically I've got to go through, I think it's this plug. The only reason I think it's this plug is it goes up to the general area where this key sort of goes up to. So I'm going to guess that's probably where we're going to look. If I put my power probe up onto a certain pin up here, we'll see that it's got 12 volts coming through, or 11.9. Basically, this is telling us that there is power there now. So if I was to quickly flick this to starter, it's staying on, which is good. But if I turn it off, it's staying on. That would mean our ECU would stay on the entire time, and the engine would also just keep running. So that's probably a little bit undesirable. So what we've actually got to do is try and find the actual ignition switch. So it could be
This one maybe? Well, there is a ground on that side when the key is off, so that's actually a pretty good sign. Let's try and turn it over. So that's got power on accessories. Oh, just got to keep that a little bit more stable just for the testing. So we've got that on accessories. So I already know that that's probably not going to be the one, because we want the next one. We want the actual ignition. If I was to, actually, that's probably a good test also, just to show you what it actually does. If we go to ignition, that also stays on, which is perfect. But if we go to the starter, it turns off. That's not what we want, because the ECU will actually turn off when we go to start the car. Not very helpful. So I'm going to try this last big power wire up here, which has got 12 volts. We're on the on. So if we go back to accessories, that's looking more positive. That looks really good, because accessories, the ECU won't be on. On, we've got 12 volts coming through, so the fuel pumps will prime. And then if we hit start, it stays on. That's really good. If we let go and go back and back, that's exactly our wire there. So a expert that uses yellow electrical tape has already been here. So we're just going to undo his amazing work, and then we will find out a good place to splice this pink ignition switch into here and neatly tie that all up. When I said we've had problems with this car and this ignition switch before, it's actually just twisted together. That could be a bit of the reason why this has just never been amazing. So we've rejoined that absolute disgraceful stereo installation spec twist and tape. So we've done a very nice crimp, a big solid crimp on that, and pulled that back together. And now we should at least have a very nice, reliable ignition switch. I'm going to maybe just redo the yellow non-quality electrical tape, and then put on a bit more quality electrical tape, just so we can ensure that nothing shorts out under here anymore. And I can see, starting to find them all again. Just going to remove all this yellow disgusting tape, but while I am doing that, I thought I might pay tribute to the OG wiring guys of Haltech, Kentucky. Andrew and Jason. Oh, look at that. That's another twist and tire. That's amazing. So that'll just fall apart. But anyway, Andrew and Jason doing an awesome job of designing and making a lot of our pre-made looms. So I actually got a lot of my inspiration and design technique, particularly from those two guys and the way that they make their looms. So epic props to those guys for the work that they do. So thank you, Andrew and Jason from the Kentucky office in the US. You guys kill it.
So we're at the back, we're at the business end. We're getting ready to do the final few things, really. We're getting very close. So I've got the transmission fan, a couple of fuel pumps, and the power steering. Power steering is here. I consulted the internet, and the internet said, join all three of these wires to the output of your relay or an ignition switch. So that's what I'm going to do. There is a power that needs to be extended. There's a number of different ways we could do something that big, so we'll just figure out the best way to do that. I'm going to ground this side because that's the ground for the pump. So I'm just going to, instead of boring you with wiring up the entire fuse box, we kind of already covered that in the earlier video where we did our engine fans. It's just going to be exactly the same thing, but we're probably just going to use a slightly bigger gauge of wire, and that's because the fuel pumps draw a bit of juice. So we're going to use a bit thicker, maybe like a 5 or 6 mil cable, and we're going to do the fuel pumps. So I'm just going to use these 12 gauge wires for the fuel pumps. There is 2 of them, and they'll be sort of situated in this sort of area. We haven't got that new carrier, that hasn't arrived yet, but I'm going to guess or assume that they're going to be some pretty beefy posts. Those two beefy posts will actually have two 460 or 525 Walbro pumps, so it is going to take a bit of juice. So it does say for one of those pumps to at least use one of these wires. So we're actually going to run two of these wires, and both of those will go up to this terminal, and they're going to run off two separate 30 amp relays to power these fuel pumps. So I've rigged up our fuel pumps. So we've got both of those, a positive and a negative up here. We're grounding these to exactly the same place the battery negative terminal is essentially. It's up here. So that's where we're going to ground the fuel pumps straight to the battery negative, and this is coming out of the relay. So these are fused and protected. Once we get that cradle in, we know exactly how big those posts are and the eyelets that we need to put onto those. We'll crimp those on. These are going to be the feeds that are going to go up to the battery positive. These are my two for my fuel pump relays into the actual fuel pumps themselves. I've got a small one for my power steering switch, and then I've got the transmission fan here. So they're all going to go through the nice neat little hole that we'll put in the back here, and then these will latch straight onto the battery positive terminal when we replace this. So I thought I'd quickly just show you what a transmission fan actually looks like in case you've never seen one before. So basically this is it here. We've got our power and our ground wires. So that's very, very simple. We're just going to ground that to somewhere existing under here, probably this nut here, which is actually mounted to the chassis of the car. So we'll just repurpose that. So that'll be really, really good. We'll use the positive, which is going to come from our relay box, and that's going to go onto our fan positive. So that's going to trigger that. So we'll try and do a nice neat install, maybe through a small grommet under this side of the car. So that'll be nice and easy. Apart from that, there's not really that much going on here. Basically, the transmission output for the fluid actually comes into the top up here, and then the out goes there, and then the cooled fluid then goes back out into the gearbox itself to keep the transmission nice and cool and working really well. This is the funnest part. I'm wearing, luckily, my brown pants, because this is literally the moment of truth where it either goes really, really well or it catches fire. Brown pants is fairly obvious as to why. Anyway, let's see what it does. Oh, that's the throttle doing its thing, so at least the throttle's powered up. Oh. Nothing's caught fire. I didn't see any smoke erupt from anywhere, so far things are really, really good. The dash is lit up. I'm going to do the best part about the actual dash itself. Looks pretty cool. We need to actually screw it in properly, obviously, but I'm pretty happy with how that looks. So I'll send some photos off to the guys and let them know that it's all powered up and it's looking good. The ECU has powered up as well, which is great. I've got the radio, so at least I can enjoy some tunes on the FMs tonight. So I think that's really, really good. Pretty happy. Well, that's pretty much going to be a wrap for this video series. I am going to leave it here. We are finished with most of the wiring. I reckon we're about 85% done. There is a few more little things that we need to neaten up, tidy up, finish, complete. But this is going to go. This is going to go get some more fabrication done on it. The owner's going to finish whatever parts of the engine he actually needs to finish. There isn't actually any parts underneath those LSX covers, so he's got to put some rockers in and mechanical things. I'm not really sure. So he's going to go do that. There is a bit more painting to be done, as you can probably see. So we're going to do that. We're going to get a bit more dash action. We're going to finish up, neaten up, hopefully get a roof lining. Hopefully about 2 or 3 months, this car will be finished and it'll be back. And then we'll do a Q&A of all your questions that you have asked over the last 8 or 9 videos. We'll try and address as many as we can, if not all of them. We'll try our best, and we'll go through the car and we'll show you whatever questions you've got. We'll try and answer them the best we can. So, guys, I want to thank you so much for sticking by me with this video series. It's been a very long process. It's been long for me and it's been long for you guys, but hopefully it's been really informative and that you've picked up at least one or two things from it that you didn't know before, or a quick tip or a trick that's going to help you get your loom installed really quick and really nicely and professionally. I'm going to go home and introduce myself to my family again because I haven't seen them in a while, so that'll be fun. So that's it. We'll wrap it up right there. We'll see you pretty soon with some more updates for this car. Thanks, guys.